All right. So I think it's like 6:02, and there's like 27 people enrolled in this class. And I happen to have something related to the content of this lecture from my research program that isn't like required for you to know. So I'm going to talk about that for like 10 minutes, which is going to be interesting. And then we'll go over the final because I was going to do that first. Um, Today we are doing something called k-means clustering, basically. I think that k should be italicized, and I feel a little bad it's not. I've been trying to be disciplined about like um, italicizing the lowercase k and k and n and things like that. I think we should be specific about these things. But this was so interesting to me because k-means clustering is the first thing that I have used in published research that we've seen in this class. And I can give an example of that, and I'm going to step you through the process for, to me, how this exists in real life. The thing I was doing was I was looking for security bugs in hardware designs of open source CPUs. So that's kind of specific, right? It's sort of data science methods applied to computer engineering, perhaps, right? When we were working on this originally in like the 2018 to 2020 area, my group was probably the only team that was not using physics or chemistry to try and solve this problem. We were using what is now called data science, and it was probably called data science at the time too, but no one had told us yet. So how does this work? Well, um, I used to do research. I still do too, but I used to do it as well. Um, this thing right here called Isadora, named after Isadora Duncan, the ballet dancer. All of my things are named after ballet concepts. I got to see Marilyn, the world premiere of a ballet by Danny Rowe, the artistic director of Oregon Ballet Theater, this weekend. It was wonderful and also horrifying, so only watch it if you want to be sad. Some of you may know Marilyn Manson's life was tragic. Um, Wait, did I say Marilyn Manson? Marilyn Monroe? Maybe my life is tragic. Marilyn Manson's life is also tragic. Okay, so I'm just gonna click on this, and you can see like what a publication I made a few years ago looks like. Um, this idea, what industry was interested in it when we did it. They sort of lost interest over time when they found out that I was super into open source and giving everything I do away for free. Um, So we were gonna patent this, and then I was like, I don't believe in intellectual property, and then my co-authors got really annoyed. But you don't have to do that. You can do things. Um, Hardware designs, right? Okay, so I'm gonna do Control F, and I'm going to look for something called daikon. Um, daikon is, where is it? Daikon is one of the first technologies used in the implementation. Um, I think commonly students in this program, a lot of the data you get is probably coming from someone giving you a CSV file or you scraping the internet. That's not where my data came from. My data came from developing a program on my computer that pretended to be a different computer, and then using my computer to pretend to be that computer and write down what it was doing while it was pretending to be that other computer. So all of my data is about the internal operations of how a computer, a piece of hardware, works. And so within the pieces of hardware, there's things like transistors and resistors and all those things that the physicists know about, right? And they either have electrons in them or they don't, right? And so I was writing down whether the electrons were in them. Now, um, I don't know that we necessarily care about Tortuga Radix S or Questa Advanced Simulator. But Questa Advanced Simulator was the thing that was pretending to be a computer, right? So what was it was doing? It was generating traces. You may have heard of traces before by a different name. A trace describes the state of some internal element of computer of a component of computer hardware at a given point in time. We may call that an observation. We observe that the clock signal is 1 or 0. We observe that the x variable contains a 10 or a 16. So what these traces are is they're actually naturally occurring tidy data sets. So you can actually, because there is one observation per line, and the line specifies what part of the computer hardware you're observing and the value taken on by that computer hardware. There's a lot of data and sort of compression that goes into it, right? But this is actually just a tidy data set. And I take that tidy data set, and I feed it into Daikon. We thought when we did this, and we don't know for sure, that Daikon is famous and valued by the software engineering crowd. We don't know that because none of us were software engineers. We just seem to have gotten a lot of citations. But let me show you what Daikon is. So if you just Google Daikon, you actually get this lovely radish. It's very pale. I think this, to me, looks like what would happen to a radish if it became a vampire, right? So I think of them as vampire radishes. But if you look up the Daikon invariant detector, you get this web page that is ambiguously, it's UW and it says Washington in there, but I think this actually came from UW Wisconsin-Madison. So I think this is just affiliated with two different UWs, and I don't know how they decide which one is in charge. So that was a little bit interesting. Daikon is old enough. It is from the era before every single piece of software ever written was just hosted directly on the GitHub page with all of its source code. But we can, in fact, find the Daikon GitHub page. It's linked right here, and they added it later in life. I'm going to skip over this page because I don't think there's a lot of things that are particularly interesting on this page. But we can directly look at the source code, which to me was a little more exciting. Also, some of you may have noticed I have a new computer and I don't pay for Windows, so this is a stolen version of Windows. So if you find that distracting, I am more distracted by the presence of trillion-dollar companies that are charging full price to academic users, right? So that's what is actually distracting you, right? Not me being cheap. So make sure you write that down and don't forget what we're doing here. Okay. What was I talking about? Oh, look, it runs on Azure. Okay, so somewhere in here, there's a reference to k-means, and I don't know where it is, so I'm going to put in the term cluster. Is that maybe going to find it? Oh, here we go. It's in tools. Okay, so this is a relatively big code base. I actually thought this whole thing was written in Java. I didn't know that. I looked at it, and it's actually 40% C, Java, C++. Those are just the only languages that existed in like 2003 when this thing came out. I don't even know when it came out. How old is it? It's old. It's like super old. Anyways, to me, something that was interesting about looking at this repository, right, is all of the techniques that are used to do what we now call machine learning pre-exist all of the languages we use to do those techniques, right? So the first people that were doing k-means clustering, they couldn't have done it in Python or R because they were doing it before then. I think the oldest technique for doing k-means clustering is called Lloyd's algorithm, and I learned about that in my algorithms class when we wrote the code in C, which came out in 1969 or something like that, right? Very old ideas. And now they're easier and faster to use. And these days, we don't even ask students to learn Lloyd's algorithms. We just tell you about k-means clustering, and you call a function in R where someone else wrote Lloyd's algorithm. And I don't know who Lloyd is. I'm assuming it's Frank Lloyd Wright. Maybe. Is that a real person? Is that the same or a different person than Marilyn Manson? Anyways, here we go. We click on tools, and then we have examples of two different clustering algorithms. These are, in fact, the exact same clustering algorithms that are present on these slides for discussion today. And these are 12 years old. That is old. They're going to middle school, I think, right? They're learning. Yeah, right. This stuff is older than some of you, right? That's how out of date I am. And see, they changed it to C++ at some point. But here we go. We can look at just k-means clustering, and this is, I guess, what machine learning looked like 24 years ago. Oh, look, there's integers. Where I saw an integer. Where is it? There it is. Look, it's an integer. In this language, you have to specify the type of all of your variables before you use them, right? But this is an example of k-means clustering written in a language that doesn't have data frames. So they weren't using data frames for this at all. They were using something else. What were they using? Probably they were using point. And so they were keeping track of the dimension, the cluster number, whether the cluster changed, data attribute, and some sort of ID, right? And so this is all k-means clustering is. It's probably easier to work with now. I will step through and I will talk about a little bit of it today. But I wanted to show you that this is something that's been around the block a few times. I was under, and I've mentioned this before, strict instructions not to refer to any of that stuff as machine learning because it didn't use neural networks when I was doing it. And I think that terminology has relaxed, and we no longer have to claim it's not machine learning. So today we're learning about k-means clustering. It is unsupervised learning, which means it's in between the supervised learning of things like naive Bayes and KNN and linear models, and deep learning, which we're basically just going to introduce so you've gotten a little taste of it, a little amuse-bouche perhaps, right, before you go into Python for data science over the summer. Okay, let's do some modeling reminders. So it is actually impossible to count to 14. No one has ever done it successfully. So not a single one of the MSDS classes has any idea what its end date is going to be until like 5 minutes before it ends. And we're like, I think we've met 14 times and no one knows for sure, right? Like, if you had to guess how many times have we met in this class? Right? 0 guesses. No one knows, right? It could be 50, it could be 0. Like, we have no idea, right? I couldn't even guess the logarithm, right? I don't know how many digits the number of times we've met is. But anyways, I went back and I looked at my records, and apparently this is number 12, right? Which means next one is number 13, and the one after that has to be the last one. So the next one's deep learning, and the one after that is the final, right? This all makes perfect sense to all of us. Does that sound... Does it make perfect sense? Some of you look sketched out. Kendall, why are you looking at me like that?
Mostly because time is soon, but
Yeah, I was...
and also
Yeah, we're out of days. When do your other classes end? Okay, I don't know. I think it probably comes down to the MLK Day lecture, which might be what's contributing to. Anyways, what this means is, by my counting, I was pretty sure I was supposed to be done the week of 21 April. And I've been wrong before. And I do think we hit 14 by 21 April. And if I don't, I will come talk to you about deep learning for one more week. That's no problem. I can talk about machine or deep learning for an arbitrary number of weeks. It is a large topic, right? And I could also do things like we could do like a technologies lecture. But the plan is k-means clustering and the other clustering algorithm, but really k-means, and we'll talk about why. So k-means clustering this week, deep learning next week, final presentations on the 21st. Probably if I'm like a cool professor, I'll like bring donuts on the 21st or something, but I bet I'm gonna forget, so don't plan for it. But if donuts show up, remember I'm a cool professor, and if they don't, remember I'm not. Right? Okay. So model to do next week, 14th April. Final due week after that, 21 April. Okay, the modeling project. This is the bank data. Remember churn? I was reading a completely unrelated like blog post or something. I was about like there's maybe gonna be like a bank run or something, which is like not funny, but like it's easier to laugh at it than think about it, right? And everyone was like, oh, we should predict bank churn. And I was like, hey, I know what that is from the class I'm teaching, right? So I guess yeah, maybe bank churn is like when you change which bank you're at, right? Not me. I've been at Wells Fargo since 2008 because it was one of the 3 banks that didn't fail. Am I happy about that? No, absolutely not. But like, what are you supposed to do? Anyone want to defend a credit union? You can do it probably using the FDIC. They're insured. Yeah, you won't lose your money, right? Okay. Cool. Anyways, use bank data predict churn. Use exactly 5 features. You don't get 10 this time. You only get 5. And we're gonna use the area under the curve. And like that slide says, we'll leave time at the end to get started. And of course, we'll find out if there's time at the end when we get to the end, right? Um, oh, click me. Okay. Um, oh, it's an example of the format of the final presentation. I wonder where I can find this if I forget it from the slides. Well, I still think you haven't needed anything that isn't on this page. I think some of you are taking a class from Professor Jed Rembold, who does this inverted, so it builds up from the bottom, so the current things are always on the top. But when I do that, my reward center is going to get triggered because I feel like I've accomplished nothing and I'm still at the same place on the page. So you have to scroll past exactly 14 entries to get to the final presentations, right? Okay. So let's see. We've got some instructions. Okay, let's open that in a new tab. I'm also going to unfull screen this because we're going to be clicking between pages. I told you all about the Pikes Peak Marathon. I ran 10.5 miles today, which is like not something that I do normally, and I've felt better. Okay, I've also felt worse. Okay, and then here's some quarto markdown. Okay, so I've opened 3 different things here. I've opened the final page, the final presentation, and the github.com/cdpub, and each of these are the same information. It's the same content, but it's presented or rendered in a different way. I'm going to start by showing you the final page. You are not required to create a final page. I thought it might be easier to lay things out this way. I have specified the goal of the final, how to submit the final, and I have made some discussion of how to create a project. I would like to emphasize at this point in time that this page that you are looking at right now, the final page, and the presentation are compiled from the same Quarto Markdown. The only difference is that one of them has a flag set to be reveal.js, and the other one does not. And I also have some theming on this page to be consistent with other things in class. I have heard students refer to when I click on these bright screens as flashbanging, but I wanted to show you the default. So that's why this is the only bright thing you see all term, right? Okay, here's the final page. Here's the criteria. You're going to make 10 features. Okay? You may use any libraries, and I suspect you will need tidyverse and caret. I do not expect tidy text to be useful having looked at the data, but you might see something I didn't see, right? So you should always have in the back of your mind, hey, by far the most successful thing we've done ever this term is tidy text, right? And we've seen things a little better than that, right? We did dimensionality reduction last week, and that worked pretty well. But we did that over tidy text, right? We reduced the dimensions of a tidy text data set. Okay. There's a reference to Ozzy Osbourne. I am presumably the person that added that to this page. And that's because the data frame is called Craven Train. And it's named for Craven Speed, which I think is like an aftermarket car parts company that presumably Jamison Watts knows about and that I've never heard of, right? But it looks like pretty interesting data set. You are going to write an engineer function, and it is responsible for driving a train through the Pyrenees. Just kidding. It's responsible for feature engineering. Okay. Here's an example of a very, very bad feature engineering function. It selects the first 10 features that already exist. That earns 0 points, right? Okay, so do not do this. At least pick the 2nd through 11th feature, right? Don't do that either. That was a joke. Okay, sorry. I'm being serious right now. Okay, engineer your features to try and get a better area under the curve. You are supposed to be judged based on profit, and I found it interesting. I did not know how to best figure out profit, so this is the metric I'm going to be using, and I encourage you to use this metric. But if you find a better way to generate profit, especially if you're someone in the MBA program and knows what profit is, I'm happy to talk to you about that. My understanding of profit, it is that it is revenue less costs. And my impression from this data set was that I had a revenue metric, and I did not have a cost metric, but I had a cost per unit and I had a number of units. So I subtracted cost per unit times units from revenue, and I expect that to be profit. And you can also be a prophet by predicting that the Lisan al Gaib will come in free Arrakis, right? So we all know what a prophet is. Okay. Any Dune 2 appreciators? No? Tough crowd. Oh yeah, there you go. Yep. I wasn't convinced by Dune 1. Okay. It's just one Dune, right? Like you need at least two of them. Okay. And then here is how I was going to do this. I thought this should be linear models. So this is a final project, right? If you want to use some other models, you should do that. But you should also complete in this discipline, is my impression, right? So if you find something really cool to do, you should do that. Dimensionality reduction, of course, I view as a good way to figure out what features to use. So I suspect you will want to do that. If I were to do this, and I've been speaking to some of my colleagues about this, so I want to encourage you to have some sort of principled design flow. I would probably use a bunch of different methods and get to know the data set in a sort of exploratory inferential data analysis perspective, and then from there figure out what I think the 10 most interesting features are. And some of them will probably be non-trivial to engineer, and some of them might be very easy to engineer. But the important thing is you're going to be creating a linear combination of 10 features that are supposed to highly differentiate successful products from unsuccessful products. Raven Speed. No relation to the recent film of the same name. This is a movie, right? No, with K? With K? Yes, Craven. Aaron Taylor Johnson. This is a different Craven. Okay. This is Craven Speed. And so if I were you, I might want to like click around on this website and try and figure out how cars work. I understand that many of them have 4 wheels and 2 doors, and some of them have 4 doors, and that these are differences, right? And then that was the extent of my knowledge about cars. Oh, I also know they're manufactured, because I know people that make robots that make cars, right? So we have free domestic shipping. That's us. We're domestic. Okay. Did I open the final presentation multiple times? That's odd. Okay. I am going to show you the example final presentation now, but I want to ask if you have any questions. Okay. I fought very hard against the cultural dominance of the slide deck as like the only form of accepted interhuman communication, right? And I think I've lost that fight. All of my course evals either say, use a slide deck, or they complain about unrelated things once I start using a slide deck, right? So the slide deck is the most in-demand thing I do. I taught here for a year and a half using only board talks and live code, and I thought it was glorious, and everyone hated it except me, right? So if some of you knew me at that time, sorry. No, I'm not sorry. I'm not apologizing for that. Okay, this is a Quarto Markdown document rendered to be a Reveal.js slideshow. Reveal.js is the name of a open source, which was important to me, presentation technology that runs in web browsers. The JS stands for JavaScript. That doesn't affect you at all. Here is how you use Reveal.js. You go to your Markdown document. Can I make this larger? There we go. And you specify that the format is a Reveal.js slideshow. You can do some niceties here, right? So for example, I can use embedded LaTeX inside the authors, which is kind of cool. So this document turned into this presentation. Now, there is one other thing going on here, which is that this presentation is living at a URL. It is publicly served at a URL. This is a requirement. I am requiring you to be able to publish your work. I just showed you earlier an example of a publication I wrote while working on my doctorate, right? That is posted publicly, and as part of the peer review process, anyone in the world can see that, right? It's not paywalled. It's on my website. It's on IEEE Explorer's website. It's all over the place. It is in more places than people want it to be, right? But it is important that when I'm trying to make an intellectual or academic or scholarly contribution, that it is public. If you are nervous about having your name on the website or on the internet, I have allowed you to present by team number, right? So just do that. And that is the way to anonymize this. Will someone still be able to figure out who you are? Yes, but not more easily than they can do anything else, right? And if you're nervous about digital privacy, I'm happy to talk to you about that and we can come up with some solution. This is the same information you saw. And as you're going through here and clicking this and looking at this, you're probably perceiving that the thing that is causing slides to change is single optothorpe sections, right? I am going to denote you are not expected to include code in these slides. That is part of the non-technical manager conversation. You are able to embed code in these slides. When do I usually embed code when I'm not able to see code? I might want to show like a list of something and it's easiest to format it as if it's code. So I often use this as sort of a rich styling element, right? So you can play around with this and see what you think. So this is a Reveal.js presentation. Where does this Reveal.js presentation live? So I have advocated for and recommended the use of GitHub, which I think is the easiest way to do things. This is the course GitHub, and you see it is deployed under GitHub pages. I have released code through this page 51 times. So there's been 51 updates this term. Exactly one for every number smaller than 52, right? This contains a variety of different code and different code bases, and it is relatively complex. But I have the Quarto markdown in a source directory here, and I've gone through a series of processes and steps to get this to build in GitHub pages. Okay, let's come back here and just look at the top end again. And I'm going to show how I got this to show up on GitHub pages. This was the subject of the MLK Day lectures. Lectures? Yes, there were 3 of them, I believe. I go to settings. I go to pages. I deploy from a branch. GitHub Actions is more complicated. You are welcome to use that if it works. I'm not going to teach you how to use it. It is interesting to learn, and it was the subject of a lecture in another class. So we can go back to deploy from branch. And then I am deploying from the master or main branch. Master is a depreciated name. We're trying not to say that anymore. We say main instead. But by default, you will say whatever that is built in. So if you are stuck on getting GitHub pages to work, it is worth your time to get it to work, and I will help you. The best way to do this is to have more than nothing up on GitHub pages next week and ask me in class. It is my preference that you do not delay until after we are not meeting again until you are presenting the final to ask me questions about how to present the final. So that is why we are going over this in detail this week. Okay, 6:30. Who has a question about this? No one? Does anyone have a question about anything else? Why does an octagon have 8 sides, right? I don't know. These are the things that are keeping me up at night, right? Okay. Okay. Clustering. Okay. Show no code, find 10 features. That is your job. I have tried to model. I don't have a what buttons do I press? I don't have a systematic way to describe the process of naming a feature or intuiting which features you want to look at. I don't have a sense for do that. My perception when I analyze my own thinking is I just look at a bunch of numbers and pick ones that seem to look large. So it's almost like a visual conception. Um, and then after I do that, I try and invent just some word to describe them. And I think it is fine to call a feature feature one. And I think it is fine to call the feature that seems associated with this thing about the data set I've noticed, right? So don't necessarily overthink the 10 features, but do imagine if you are presenting something to a non-technical manager and you're saying, hey, I have come to the conclusion that things that are red between $100 and $200 and end in the letter Y in their description are all going to sell better than things that don't have those three attributes. You need to have some narrative or way of describing how you came to that conclusion, how you demonstrated that conclusion, right? What I always say is the narrative doesn't have to be correct because it's difficult to assess the narrative, and a lot of times the importance of narrative is just to describe or communicate. It's not to it's not even necessarily to persuade, and it's not necessarily about doing science, right? The science has already been done numerically. Um, but you are going to have to describe results you find from various methods in your life to various people. And I think it would be a good use of your time to practice that with these 10 features without the use of code. I always feel like it's a little too easy to explain why you're doing something with there's code, where you change one thing about the code and you show that the RMSE goes up, and then you say, well, that's why I didn't do that. That doesn't necessarily confer insight, and I think it's also not persuasive that you know what you're doing, right? So work on building some form of narrative arc. I will say, and I have not emphasized this and I have not taught this necessarily, one of the outcomes of an MS program should be your ability to stand in front of a room of people and give a talk on something. Okay. Supervision. Wait, I have to tell you how long the presentations are supposed to be. I think there's 19 groups, and some of them have non-integer numbers. And I think that we have 3 active hours of class, basically, because there's going to be some setup and teardown time, and we also have to take dinner. And so 3 hours is 180 minutes, which divided by 19 groups is exactly, without rounding, 10 minutes per group. Did anyone catch that? Okay. What? No, that was wrong. Goodness sakes. What is it?
Well, I was just confused.
Okay, 18 divided by, or 180 divided by 19 is exactly 10. Okay, so it's exactly 10. We can all agree it's exactly 10. So you have 10 minutes, right? 10 minutes including pulling up your URL and then speaking. You do not have to use the whole 10 minutes, but you get 1 minute per feature is the way to think of this. So keep your presentations under 10 minutes. If you are still talking after 10 minutes, I will start yelling over you, and it will be embarrassing for all of us, okay? Yes.
Just to clarify, what page you want to make?
One slide deck per group. Yeah. No, you can share a page. That's fine. You just have to be able to present from a public URL. Yeah. Okay. Supervision is the thing that the Cyclops from the X-Men has, right? Tough crowd tonight. How's everyone doing? Not bad, huh? Okay. You're usually so energetic. I'm energetic. Okay. Also, my voice is in shambles. Hmm. Is everyone sick? Is that what happened to us? Is it the rain? Oh, it's dark. Okay, yeah, no, that makes sense. Is the lower brainstem getting us? Like it looked wrong, right? But I was like, someone said something like up there. I was surprised. So thank you. Cool. Actually, I should make you all talk to each other and go around. That'll get you talking, and that'll be good. These are useful, motivating questions to discuss. You should be very, very good at explaining the difference between supervised and unsupervised learning. That is one of the most useful things in the universe. So find someone near you and explain the difference between unsupervised and supervised learning to them, and make sure you both are convinced that you sound like you know what you're talking about. And then the other thing you should be able to do is be able to understand it well enough to make informed decisions about what code to write. So that is the way to tell if you are correct. Then answer these other questions, but I think the first one is the most important one. Ready, go will take 15 minutes and then we'll be energetic when we come back. Okay.
So like, nothing but they're like, hey, you're right, that's this. That's supervised because they typically don't. So it's not the ideas. They have this gas on this, like they've got just or so there is no answer to this. Yeah. The most same thing. Out. So. Were you just like how there's something.
They do it fast, it's just because of super someone. Right, yeah, that's the office of like, it's more than shit, soccer. Yes, you can have, so something. And then the ease of the times. We didn't want people to like more money. So there's one very. Oh, yeah, that's like this. We know we're really good around. Like, I'm not. I think I'm shoot because I'm she's like, sure. He does not around to do it. No, I don't like it. So we're. If there were the other reason why was then my favorite is not going to make it. I don't like the other thing. I'm moving this to this. Like, it's very good. Not like the I'm saying essentially, it's hundreds of lots of yes. Like let's change. We did like this other line because that's the basic option. Well, actually, there were any songs. There's sometimes I'm trying to use it for just like subsidy. You know, it's basically like, you know, it's like if they were exactly, it's great, like, our stickers are yes. It's so many much different. I think or at least it's personal. Because when I usually follow you, they have like this sort of knocking on the process. Especially the market, so it's okay. Sort of yeah, like you don't have any it's pretty big on the whole 12 so like probably because it's on this like other you don't really consider it or what is your thing basically it's like oh yeah it's like you know, it's it's just it's nice and like we're into the film I was very yeah or yeah it's a big thing so we don't can't really notification it's not very outside of oh the cancer I see the passion for the oh, that's kind of that's kind of but I feel like that's not what it's it probably wasn't yeah, so like if we did right so that's we're trying to here the things like somebody is this option that's not what we change. It's there's a bunch of stairs. Yeah. Yeah. That's basically what I'm doing. It's
I didn't know it's Scott.
That looks something more.
I was sad. I put that there. So that was Sky. Yeah, no, see, I was.
Maybe we'll always see like what's going on with. There's so many important pages. I feel good. Yeah, yeah. Yeah. Raw. I don't know where to find these. Was crazy, bro. Yeah. We're supporting the required so that it's season. So it was something else. It's great.
I was like.
Yeah, we're in trouble. I'm good, like, we can't access all of them. I know. So it's good. And yeah, the guys are thinking. You have some space. You know, so we're interpreting. I was assuming, I was waiting to go the other day. They're back there and the double decker we have to do very much of trash. So, no, I'm sure that I wouldn't make them. It doesn't feel like when you do the you do the out and then it'll start. So and the distribution. You split it off and save them something for life. Well, I don't really think whether they're kind of integrate how that it is a part of the something. Especially because we're making a lot of values. Because it's so bad, yeah. So if I pop it in number one, you're that is the and it is just like the yeah, that's why I want to it's for all
On the line.
No, this first, okay. Says major leagues. I mean, on the roster, I mean, so you're starting for like what are we trying to do? Emergency starting off date. Hitting certain that's the way that it needs to go. Like I know there's something else. Imagine because you must have nice material and you use much. this guy's into place first base. Those are. Yeah, or you can other places that these guys have. These are most guys are these firms. Like and my effort been on for those ones software savings. It's very rarely new what's the cost there. Usually they're base realities. They're or sometimes they're like usually just it's yeah it's weird
When
it yeah. Yeah, it makes sense. So this especially with what if you want usually for a specific project. You better look at first those specific, it's supposed to get modified to if we're exactly. Like you better look at just like your virus, you can't have slow virus like your stuff. Yeah, that's for work. Technically. You know, I'm
Why? Wait, what?
This is lighting for power. Is that for 100%?
That does look like there's a heart. I don't know. Cool. Yeah. Okay. Hello, students. Welcome back. So I'm going to advocate for the usefulness of supervised learning because there have been times in my life I've been looking at data sets and I've suspected there was a pattern there. And it was not immediately present in the data. The most common time this happens in my experience is when I'm looking at registration data for undergraduates. For years and years, it was reported to me which classes were the most and least popular, and it seemed to change every term. And then someone looked up which classes were in the morning and in the afternoon, which had not been in my data set. And I still have to wake up at 9:10 a.m., but I no longer have to wake up at 8 a.m. So I was really, really motivated to find that data, right? We've also found that classes without a lab section are more popular, and we've also found that classes taught by the professors that you had last semester are more popular. That's why they taught the first semester to get you to join this program, right? No one found anything about the classes I teach, and we don't want to think about that too much, but we've got you now, right? Very commonly, there's a question that you're not sure the answer to. I'm going to comment on the news briefly. I'm sorry. There was some consideration when the tariff. No, stop talking. What was it? Tariff. The tariffs were announced. No one could figure out what they were from because it looked truly random. And it obviously wasn't random because Vietnam was the highest, and Vietnam is the most rapidly industrializing nation in the world. So there's your first hint, right? So anyways, some brain geniuses threw numbers at things for a while and found out, I guess the tariff level is something related to trade deficit divided by either imports or exports. I don't know. So it's actually just a linear relation to known elements of the data frame, right? But no one knew that until you started looking at it. And then I think something else that was actually very interesting from a classification perspective is I don't really spend a lot of time talking to the AIs anymore. Sort of outgrew that about 2 weeks ago. But I guess if you ask every enterprise level, like GPT-4o and all of those, they all suggest that if you want to do reciprocal tariffs, that is the most obvious way to calculate it, right? So that was interesting as well, where we found sort of an emergent cluster in, we'll say like US federal policy. There was the cluster is actually those policies which can be generated by multiple generative AI agents, right? Which is pretty interesting. I've been sort of barking up the tree of computational government for some years, suspecting it would produce higher quality policy outcomes than the United States Congress. And I think I've actually disproven that now, right? So whatever the United States Congress does, it is in fact, I don't know, like more efficient in the eyes of the Dow Jones Industrial Average than governance by ChatGPT. So that was just an example of like something that was in the news every day, and the first data scientist to figure out like, wait, this is a linear relation between two numbers I know. That's pretty cool, right? Um, okay, supervised learning uses labeled data. What do we mean when we say labels? We mean we know the answer. So when you used supervised learning, you've got a bunch of stuff that you know the answer to, and you're just, wait, why is power and sleep settings popped up there? There's definitely a heart. Okay, sorry. We're gonna close that and we're not gonna get distracted. For sure. Okay. So, sometimes you know the answer. Sometimes you have years of historical information, and it is only the most recent data that is coming out that you do not already know the answer for. That is how I always think of it. I always think of this temporally. It is not always temporal. I gave the example of studying hardware designs. When I got really convinced I was clustering hardware correctly was when I applied my clustering algorithm to a design where all of the registers, which are the things that hold bits and bytes, were labeled. And I was very, very close to exactly predicting their labels, right? And then I knew what to call all of the labels, right? I was like, oh, this one's called debug. I didn't know about that, right? So that was very nice, right? Sometimes you find the right answer. We do both classification and regression with this, and I am sort of not into the idea that there's significant differences between categorical and numerical outcomes, but like they are fundamentally different on some level, and we have to fidget with the internals of the algorithm a little bit to get one back or the other. But we can certainly use KNN for either of these things, right? With KNN, we just force them into some class, and otherwise we just give them some numerical score, right? Totally reasonable. Some of you may be familiar with the fact that classifications and regressions are the same thing because you're students in a class where you get a numerical grade that gets converted into a letter grade, right? One of those is a categorical, one of those is a numerical. When we say unlabeled, what do we mean? We mean we don't know the answer, right? We might still be trying to do something, and we might still be in an end-to-end process where we do know the answer, right? But oftentimes we're trying to answer questions that people have not answered correctly before. How was the tariff generated was new. That was original research. Someone had to discover that for the first time, right? Can you teach classes in the morning? I thought that was already known, but we were able to sort of experimentally verify that no, it is impossible for a 19-year-old to learn cybersecurity at 9-10 a.m. on a Monday, right? I like the notion of hidden patterns, things that are subtle, things you don't expect. There's a political, I'll call it fault line in the middle of Philadelphia that lines up with a change in soil quality because the first settler colonizers that moved to Philadelphia, the rich ones lived in the place with the higher soil quality and the poorer ones didn't. And the social structures have remained in place since colonialism. And so soil quality predicts support for conservative candidates in Philadelphia suburbs. Someone figured that out. That's like really cool to figure that out, right? You're like, oh, of course you think that. You have good topsoil under your house, right? Like, I don't know. That's like an interesting idea. Was it hidden? No, right? Like you could just go check. You could just go put some of the soil in your mouth and taste its additional micronutrients, which I think how farming was done before science was invented. But someone had to discover that data, right? And they had to cross-reference a bunch of different data frames, and that's how it was discovered. Unfortunately, I cannot find that paper because I always want to share it with students as an example. It was like one of the most impressive data analyses I've ever found, and I cannot find it. So you'll just have to trust me that there's something like this. And one of the other great things about it is because I present it from my memory, I don't know if I got any of the words right. So I might have flipped conservative and non-conservative. And also this was like conservative and non-conservative in like city council elections. So it's internal intercity politics, which is different than external. And I think it was soil quality, but there's some like volcanic or sedimentary thing that was driving it. I don't know. There's a straight line through the middle of some Philadelphia suburb that's caused by geography somehow. Anyways, the two examples of these are clustering and dimensionality reduction. To me, I find these the most interesting. And so those are the two we're focusing on. Okay. One of the early machine learning tasks was digit classification. Um, there's two letters I write that look the same. Oh, yes. My R's and B's are hard to differentiate. If I say over, um, my R's and my B's look quite similar, right? Um, you as a human may be able to perceive that that says over. This mostly came out to me as a problem. I have previously, even tonight, ranted about slide decks, right? So many students said, Calvin, we can't tell your R's from your V's in equations when it's either an R or a V. It's either a radius or a velocity, for example, right? And since it's in an equation, we can't necessarily use context clues unless we already understand what you're teaching, right? So you have to use slide decks, you have to use LaTeX. That is what I'm going to call digit classification or character classification, right? It was one of the early computer vision things, given usually black ink on a white background, so no color, which reduces the amount of noise, right? Can you tell if this thing is an R or a V or a 9 or a 6? And the 9s and 6s are really interesting because you don't always tell the image classification framework which way is up, right? That is so similar to me to this example we have right here, where you've got squares, triangles, and circles. Because what happens if I try and draw a square, triangle, or circle, right? I have sort of a finite degree of acuity, right? So I can probably get a circle pretty well. But if I'm also teaching about ellipses, you would not be able to assume I'm trying to draw a circle or an ellipse, right? I think the same thing is true of squares and rectangles, right? That is a much, much harder classification task. The first time I used machine learning workloads in this context, I was trying to train an image classifier to tell the difference between obtuse and there's the two types. Are there acute and obtuse triangles? Does that sound right? There's acute little ones. I'm sure I can refer to a triangle as an acute triangle.
Yes.
I know scalene is side length, right? Isosceles is same side. No. Two of the same sides. Equilateral is three of the same size. Oh, acute renal failure. That's sad. Okay. What about like a cute little dog? Yeah, obtuse. I feel extremely good about my knowledge of triangles. You were all gaslighting me. You said there's no such thing as an obtuse triangle. Kendall said that. I heard it, right? Anyways, the image classifiers cannot tell these things apart when I was using them. They inferred lots of properties about the triangles, but what they actually seemed to be doing is counting how many dark pixels there were. Which is, that's one way to do things. But the image classifiers were very, very good at digit classification, which is much, much harder in my view, right? So they did better with these forms of supervised learning, right? Now, of course, the frameworks are mature. They can do everything. A computer has much higher visual acuity than I will ever have, right? But not in the early days, and certainly not when running on my laptop, right? So, here's another example. This is an 18-minute video, so we can't watch it. I don't know a lot about wine, but I'm sort of okay with things like chocolate, olive oil, and coffee, which I do a little bit more of. I might try and do an olive oil tasting on the last day of class, but everyone's always like, Calvin, you can't just drink olive oil, which is false. I drink olive oil all the time. It's no problem for me at all. I just went over to Al Aqsa and they like put some very good olive oil on top of hummus, and you can just like slurp that stuff up like you're a puppy dog, right? There's no side effects. I'm normal. So, anyways, if you're an extreme coffee snob, which I recommend you be, everyone hates this, right? But it's much, much cheaper than being an extreme wine snob. Like the most expensive coffee in the world is like $12 a cup, right? So he's like, we can do it, right? Um, my understanding is at various points in the past, like 20 years, when specialty coffee's really been taking off, um, there's been very, very high scoring coffees from Ethiopia that do not taste to the best people at tasting coffee like they're from Ethiopia. And so this has always been very surprising. Now, it's not that surprising because it was generally regarded that coffee was either from Ethiopia or Yemen, and that there were heirloom varietals, so there were types of the coffee plant that grew in Ethiopia and nowhere else in the world. And you never knew for sure if you weren't just trying a new varietal you hadn't had before, right? Over time, it seemed like some of these things were way too different. People got pretty good at tasting how similar varietals were to each other, and it still seemed like there was something that wasn't adding up. For a brief period of time, starting a couple years ago, and I think no longer true, the political situation in Yemen changed, and it became possible to export coffee from coffee plantations in Yemen. And these things got exported, and they immediately cleaned house at all of the awards. They seemed dramatically better than all other forms of coffee. I tried one. It was $12. It was hard to find, and it was very, very good, right? And I drink a lot of snobby coffee, right? You all know I'm a snob, right? So you can take me at my word on this, right? But someone figured this out, and I guess, I think if I click this link, there's a business person of Yemeni descent. I don't know the demonym for Yemen. Yemeni descent, who figured this out and was trying to sell this Yemenia coffee varietal that was only grown, to anyone's knowledge, in Yemen, but had been being sold under Ethiopian labels because they couldn't sell Yemenese? Okay. Yemenese coffee under Yemenese labels due to trade embargoes, right? So this is an 18-minute video with a like World Coffee Championship winner talking to this business person that detected this varietal, went to Yemen, started bagging it because it's distributed in green coffee bags, and sending it abroad to be roasted and win awards and make a ton of money. This is a really cool thing to me. I believe Yemen is sometimes described as the poorest nation in the world, and I think it depends on how you count, right? And selling a cup of coffee for $12, you don't have to do that very many times if you're the poorest nation on earth to make a lot of money and really improve people's quality of life, right? So this was just a great case of like data science solving two problems, which is that I got to be a coffee snob and the poorest country in the world got to have, I think, higher quality healthcare, right? So that's two really cool things. And it was this great example where by international law, we couldn't have this label on our data frame, right? Someone had to go find this and market around it and like build a consensus around it. And it's just really cool. So to me, that was the most sort of immediately historically interesting example of clustering. There was this cluster of coffee that was discovered and it was unlabeled. And eventually it was proven that that label should have existed because people were able to taste coffee that was labeled and determine it was the same thing, right? So I don't think you will have a very good time finding a Yemenia coffee. I have not been able to find them for the past couple of years, but if you do, I recommend you try it, especially if you're a coffee snob. If you're not a coffee snob, you won't really know what's happening, but maybe it's like a good use of your time anyways. I don't really know what association rule learning is, but it's on this slide. Okay. Everyone loves esports, right? We're all big fans of Team Liquid. Yeah? No? Cloud9? Navi? Natus Vincere? I know Latin. Sorry, I only know ecclesiastical Latin, not high Latin, right? Yeah. Anyways, here was another interesting business example that I became aware of. So I gave the example of Team Liquid. Team Liquid is, to my knowledge, the only company in the world that is making money from doing something they call esports. There are companies that are not losing money fast enough to go out of business, and then there's Team Liquid. Team Liquid was formed in Europe around in between 2004 and 2007 by people playing StarCraft Brood War, which is the real name of a sport, right? I thought the sports were all called football. One of them's called StarCraft Brood War, right? My classification algorithm was incorrect, right? I thought StarCraft Brood War was something nerds did, right? No, it's apparently a sport. So, Team Liquid discovered they loved making money, and so they did what everyone that loves money is. They moved to Southern California, right? And they are now a North American, and they say North American, based esports organization. And why did they do that, and why can they make money, and why can their biggest competitor, which is named Evil Geniuses and is still based in Europe, not make money, even though Evil Geniuses was older and was more initially successful? Steve R. Hansett has an MBA from somewhere, probably. He seems like he has an MBA. I wonder if that's true. Let's check. Let's see if I can spell this person's name. It's going to be impossible to find out this person. James Madison University? Doesn't say what degree. Anyways, there's this real person that actually exists named Steve R. Hansett, who played semi-competitively and then took over Team Liquid by knowing how to make money. And the way he discovered to make money was he discovered clusters. And the big cluster he found was 17 to 24-year-old men who still live with their parents and have large amounts of disposable income and were about to buy their first car. And every single one of these people watched League of Legends on Twitch on the weekends, apparently. You may have noticed I drove down here from Portland today in a Honda Fit. And I'm describing a team called Team Liquid Honda. They got me, right? I wasn't living in my parents' basement, but I could have been, right? And so, in the United States and Canada, and I don't know how trade policy works with Mexico, but I suspect you can buy a Honda Fit in Mexico, probably from the same producers, right? There are around 400 million people, and there are a lot of roads, and many people buy cars all the time. If you go across the pond and go over to the UK, which used to be part of Europe and isn't anymore, that's your exact problem. There's extreme market fragmentation, in my understanding, in Europe. Europe's largest company is Volkswagen, and they make cars, so they are predominantly an industrial automobile economy, to my understanding, right? And so you would expect that if you were in the business of making money, you could do well by advertising to people that are about to buy their first car. There was no real reasonable way to do this in Europe that anyone discovered, because you had to advertise in different languages, in different countries, and different countries had different national cars, right? So, the core insight that prevented the United States from entering esports winter, which was the time where you had to spend less money on your esports team because you weren't getting as many advertising dollars, was if you moved to the United States, you were in a less fragmented market, you were in the largest cluster. Now, this cluster did exist, right? People were able to find this. But when you're just looking at Twitch viewer numbers, which was all this stuff came from, it doesn't say if those Twitch viewers are watching from the United States or Croatia, right? And almost none of them are watching from Croatia, and that really matters if you need to get money from Croatia advertising executives to go out and play video games, right? So I thought this was another interesting example of clustering in action, and I wanted to tell you all about it. I might be covering one of the sports analytics talks this summer, and I will either be discussing, I'm sorry, League of Legends or chess. So become emotionally prepared for that. Here are the anomaly detection examples. Every once in a while, my beloved bank, Wells Fargo, love them, they've never done anything wrong, suspects that someone is doing something with my credit card that I wouldn't do. This happened to me years ago, more often when I traveled, which I don't do anymore. This hasn't happened to me for a while because now the only things I buy are canned black beans, corn chips, peanut butter, whole wheat bread, and espresso. And if you only buy those 5 things, no one can successfully impersonate you. So everyone always knows exactly what any given charge on my account is, and my account never gets locked anymore. So this is a great joy to me. I think probably a more interesting example is this is the sort of the high level understanding of behavioral verification. My colleague, Marie Ann Nesfield, who's now at Microsoft Research, she did her MS on computer network behavior. And what she did is noticed that there were many, the things that go over computer networks are called packages. Or no, they're not. They're called packets. My words are not working today. They have vanished. They have taken flight. They've done this, right? The Marilyn Monroe did that in the ballet I watched, and it was symbolizing the loss of childlike innocence, which was horrifying to watch. Anyways, okay, so there are many possible ways to send a packet over a computer network, and many of them are allowed. And many times, if you are trying to impersonate someone or launch some form of attack on something, this can be done with legal packets that follow all of the rules. But even if they follow all of the rules, they might differ in predictable ways from other packets. For example, they might all come from a certain IP header associated with a company or university or nation state. They might all come at time points. For example, maybe they are all sent on the hour or 5 minutes after the hour, right? So there are combinations of anomalies in computer network behavior. This is mostly used, to my understanding, to protect websites from going down because they get too many fraudulent requests. The fraudulent requests are oftentimes formulated as if they could plausibly be real requests, but they're similar enough to other fraudulent requests that they must be wrong. There's no label on them, right? Just at high probability, this is something we don't believe in, and sometimes you'll get misclassified. Perhaps the easier way to explain this, which I just thought of right now, is many of you have spam filters on your inbox, which are not completely correct, but are probably pretty good, right? Spam is not like a real classification, right? It's an emergent phenomenon. And I believe in data 596, which is survival analysis, you might be trying to predict imminent equipment failure in manufacturing processes. I would expect that to be anomaly detection and probably use unsupervised learning. You know what dimensionality reduction is, but you extract features, you swivel them around, and then you get rid of a bunch of the ones that don't matter or are not particularly meaningful anymore. You sort of rank possible features by how powerful they are, right? And this was very similar to decision tree in that sense. Okay, what makes this hard? When I was midway through my MS program, I couldn't tell if I was ever going to graduate, which some of you may be able to relate to that feeling. And so I was just talking to my advisor about this, and I think I didn't go out and ask for help, which you should never do. This was just an unrelated conversation where I happened to ask for help, right? So I had plausible deniability, right? And I was like, hey, I can't really tell if I'm doing a good job or not. And my advisor said, well, actually what has happened is, in this case, I was after my MS, I defended my MS thesis. She said, you're actually in the part of your career now where no one will ever tell you if you're doing a good job or not. You'll just get specific feedback on individual things you do. So you'll hear like good paper, bad paper. You did a good job teaching that class. You did a bad job teaching that class. And no one will be like, Kelvin, you're a great grad student. We're so proud of you. No one says that to me anymore, right? Probably because I'm not a grad student, right? You're all great grad students and I'm proud of all of you. So, I've beat the system. But at some point when you're doing advanced research or doing things people haven't done before or novel techniques, right? There's no way to tell if you've actually done something right. Now, when I was walking around the class, I gave a few examples of times where like maybe you could do a clustering algorithm and find out if it was correct or not. You don't always know that. And I think I gave the example of like trade policy, right? There is no way to know if you have arrived at the right combination of like healthcare policies as a nation state, right? Like you just can't measure that stuff. You just have to make an informed decision and try and commit. We have no real way of knowing. I'm quite confident of this, that when it comes to curriculum design and scheduling, we can't actually measure how good of a job we're doing predicting what classes to teach. I have a lot of nervousness always around like, oh, like, do I need to teach this or do I need to teach that? We don't know. We'll never find out. We will never know. It's sometimes even the case where like you will all turn out okay, but we could have taught you this other thing and that actually would have changed what jobs were in demand in the region, right? Like you just don't know that stuff, right? And so sometimes when we're clustering, and so like I have found a few clusters, right? So there's this thing called microservices, which is like a bunch of cloud techniques that are used. It's unclear if we should teach a class on that, right? We just don't know. And that's okay. And I think that's something you should be comfortable with and feel encouraged by, right? That with computers, we can now ask questions that we don't know the right answer to. And we're not going to get yes or no answers, but we are going to find out things, right? And having more knowledge is independently useful. This is the thing I always dread, which is interpretation. I frequently think I find patterns that I am persuaded that other people will believe exist. And so I think like, I don't know, afternoon classes is kind of a facetious example, but I was an advocate of not having morning classes for a while before we got rid of them. It can be really difficult to persuade other people, your colleagues, decision makers, people you're in charge of if you're doing politics, right? So I might perceive that I have discovered a good combination of economic policies, but I can't run for office and win on that platform, right? And that can be frustrating. I think one of the most interesting examples I found was I'm pretty sure on the practice midterm, and I didn't show you all of my stuff, I discovered the difference between colleges and universities. And I did that without extracting the college or university feature. It was just obvious when you were looking at it because they all said college or university, right? I was like, these things are behaving differently. They have dramatically different sizes. They have dramatically different four-year graduation rates. They have dramatically different costs, right? So that was interesting. And that one's easy to explain. You're like, oh, it has college versus it has university in the name, right? But now many colleges are just changing their name to university because it is perceived as more valuable, right? At Willamette University, we're a real university, and you can tell because we don't just have an undergraduate college. We have an MBA program, we have a law program, we have the MSDS. So we're a real university. Don't mess with me, right? But, there's some pretenders out there too. And I think a good example, I don't know how much all of you think about this, but the Colleges That Change Lives is a emergent cluster of universities. I think, well, I guess it says colleges, but some of them are universities, of which Willamette is part. And this organization seems uncommonly good at doing things like upward social mobility, supporting first generation students. It was interesting when I came here and heard about this because I was deciding where to work and I was looking at things like what is your first generation percentage? What demographics are you serving? And I very, very close to engineered the Colleges That Change Lives feature, but I didn't exactly get it. But to me, it is like highly non-coincidental. I work at a Colleges That Change Lives university. It's like, I feel like that's mission aligned for me, right? But someone, and I think it's like a writer for the New York Times or something. Who is that person? Oh, it's a book. Okay. Right. So an author came out and successfully persuaded people that this cluster existed, basically, right? So now it is a cluster that exists, but it had to be discovered, right? And that's cool. Unsupervised learning hi, I'm a computer scientist. This is the computer science slide. This stuff costs money. It's not free, right? Especially when you're looking at big data sets. And by big data sets, I mean Netflix prize. I don't mean like classes we've offered. I don't mean number of universities in the United States. I mean, can we predict what word is going to come next in this sentence? That's hard, right? To do that over and over again. The data sets are getting bigger. They're getting less organized. The algorithms are becoming more and more complicated in the sense that they're checking each other and they're simulating personalities and they're simulating conversations. All this stuff runs on GPUs, which use rare earth minerals and can only be made by one company in the world that's based in Taiwan. It's just not easy to do unsupervised learning. Now, I do think it is true that in 2025 it has become easy. I do think the modern technology is good enough. You can pretty much do this as much as you want. But I have really noticed across the course of this term that there are times that I press enter and I write all of my R code in the R interpreter, right? So I'm not using R Markdown, I'm sorry. And then I like go make a sandwich or something and come back and it's not finished running, right? And if you do that on a data center, that can be extreme. So I have the notion here that computational costs become operating costs. If you are attempting to run an unsupervised learning algorithm over some data set, you don't actually know that there's clusters you're finding there. You might spend a lot of money and find garbage. And that is a real concern to have. And this is much, much more pronounced with the neural networks, right? I am shocked that we can use LLMs for free. And we probably shouldn't be allowed to, but that's okay. So, these are my takeaways. Not too exciting. And we are going to get into the k-means clustering algorithm after dinner. I will see you all soon. I'm going to go get a little coffee, and it's not going to be from Yemen to my knowledge. But I hope it is. Is it cold out? Okay. Yeah, I don't remember. Right. Check right now. Oh, I have to be driving. There's going to be like grades up over here, so you can't look at my screen until I tell you. Um, you are three.
I think I'm processing.
Yes, I love that.
I know there's a group exercise. Y'all are gonna have to get amped up at like 9:15. You ready to rage? Oh, you were maybe gonna go into finance, right?
Yeah.
Yeah, yeah, yeah. I see you. Yeah.
That's the goal.
Yeah. Just don't sleep. There's a meme that like Amazon is like hard to work at and they like chew up developers. I have two friends that work at Amazon, but one of them out of undergrad. He was gonna go into finance. Then he went to Amazon instead. He's like, it's so easy. like like they only expect me to work like 70 hours a week. Like I was planning for 90, right? Like yeah.
Busy season, there are upwards of 100.
Yeah, you just don't sleep, yeah. I see how they get you though. Like a part of me still wants to do it because I just want to play with numbers all day, right? Like
Stuff. I like.
you'd find things, right? I bet. Yeah. I mean, like on paper, I teach like the same six things over and over again, right?
Yeah.
But like, do I? You know? It's not new techniques, yeah. Mhm. Yeah. Yeah. You'd have to like. I feel like it would make it interesting. It's the same thing that like makes reading the news interesting, is you'd like be able to like track and predict trends,
Yeah.
and you would do that on the side or subconsciously or something, right? What are we doing? Why am I looking at these slides? That looks interesting. Oh, you all can't see this. I'm just like blasting through here. Like, look at this dendrogram. What a great looking dendrogram. I don't know that I've ever seen a dendrogram quite this good looking before. And we all know what dendrograms are. Oh, you would. Yeah. Can I interest you in a phylum or perhaps a genus? Any groups? See groups used for other stuff. Okay. That's gorgeous, whatever that is. Cool. This will run some k-means clusterin. Okay. I'm gonna say this exactly once. Every day I'm clustering. Okay. That's all. We're done. We're moving on. I gotta know if that K is supposed to be italicized. No. No, it is not. It's not even. Oh, yes, it is. I feel like ground truth here is this thing right here. Let's see if I edit this. How is that stylized? Um, I don't actually know. I guess double quote is italicized? I need to find something else that's italics. Oh well. Hey, James McQueen, Turing Award winner. What year is that? 1967? 2 years before the language that I showed you it in was invented? Yes. Okay, so Lloyd's algorithm, what I mentioned, is from Stuart Lloyd, and the algorithm was proposed 10 years before the thing was done, which is almost certainly why I was taught it was called Lloyd's algorithm, because I was taught it by algorithms people, and they would have been calling it Lloyd's algorithm for 10 years before anyone referred to this thing as k-means. And so they would have probably taken classes that referred to it as Lloyd's algorithm and like read textbooks. And so there would have just been an oral history of referring to this thing as Lloyd's algorithm. I had never heard the term k-means. I did not know what the k-means in those files stood for. I just knew it was Lloyd's algorithm. Lloyd's algorithm. And some of you may have done your undergraduate at Willamette University and met Professor Josh Lyson, who does computational or modern geometry and does Voronoi diagrams. So k-means is actually a computational geometry technique. So I was cooking some stuff up. I sent Josh an email because I'm still trying to get that math PhD. It's been elusive for many years, right? Keep trying to go back to grad school and they say, we're not going to pay you. I'm like, that sucks. Your options are night school like you're all doing, or 6 years of pain, which I would recommend. You should all do it. Okay. I had one other one about means. What is it? Oh, right. Okay. So this slide title is not to imply that K has the meaning of the term clustering. So it's not that K means clustering, right? Yeah, like play on words, like means. No? Okay. It's also not called K-nice's clustering. Yeah? Okay. We'll get going. We'll get going. Okay, we're back. We're good. Okay. Is that visible? It looks bad to me. Let's embiggenify. Embiggenify. Here, it's spelled. I'll write it out for you. Now, a lot of people think that because I'm pronouncing n-biggin, no, it's spelled m-biggin. You just pronounce it n. N, big, right? Big, root word. Biggin, ify. And this is how you make things larger. Okay. So, how do I think of k-means? Well, I always begin thinking in terms of two space, just an x and a y axis, because it's easier. These two axes gave the example of when I found the cluster of afternoon classes, right? So maybe one of these axes is start time, and maybe one of these axes is course enrollment. And then there's a smattering of courses or of any other data. In this case, this is just a learning example, right? So there's things that happen to be triangles, things that happen to be circles. So we're suggesting that there's two sort of classes here that we're going to discover one way or another. How are we going to discover them? Well, in theory, the way to do this is if you knew all of the clusters, right? You would simply be able to calculate the mean in the x and y dimensions of each of the two classes or sets, right? So the triangles have a mean around here, and that's why we have a big filled in triangle, and then the circles have a mean around here. But somehow you have to identify these things, right? And then when that happens, we're going to use the generated means to update our assessment, to perhaps not literally update our priors, but the idea of updating our priors, right? We're going to say, well, it appears that this plane, because it's in two space, is bifurcated basically along the line in between these two things, right? So your Euclidean distance, right, which I think is the distance in two space, is either closer to this triangle or closer to this circle. That happens to correspond to a cut across the surface. And so we have triangles on one side and circles on another side. You may notice, and I think this is important, this says iteration 1. You might want to do this a lot of times, and that might be a computational cost, which then incurs an operational cost. Here's iteration 2, and I'm once again going to ambigunify this. The ambigunifying was very popular the first time, so we're going to continue to use that term. What did I have open there? Oh, that was the grade book. You're not allowed to see that. Okay. It says you're all great. Okay. So you already know what it says. So you don't need to look at anyone else's, right? You know that you're great. You're valid. You're worthy. You're good. You're going to do good. You have a lot of followers on Instagram. Okay. Follow me on Instagram at Calvin Allegedly. Okay. Right. There will be pictures of my cat on that Instagram someday. Okay. The cat is not photogenic right now. She only comes out when it's dark, which is like, she's a dark cat. We can't see her. She's very sneaky. Okay. So we iterated, and what did we do? So last time, the centers were around here, right? And so we did the cut, and then we found that triangles are on this side and circles are on this side. Is this a pretty contrived example? Yeah, but we can say, oh, hey, so going back to our example of courses, which I'll say instead of classes because we're doing classification, right? Maybe this is high enrollment, afternoon, low enrollment, morning. I don't know. Maybe those are the two clusters we find, right? So once we make the cut and we perform a classification, then we can update where the means are within the class, right? So, you know, these triangles range from roughly here to here. There's a slight weighting here, it looks like, and then range from there to there. So these circles and triangles represent the means of the set. Circle already looking a little suspicious here, right? That we've got these ones over here. We got these ones over there. Are those really in the same classification? I don't know, right? Maybe this is a morning section of Data 151, a very popular class, right? And maybe this is an afternoon section of, I don't know, it's a class people don't like fourth year Chinese is famously undersubscribed because not very many people take third year Chinese, right? So maybe that's at a really, really likely to succeed time slot, but there's just not that many students that have taken the prerequisites, right? Okay, so that's iteration 2. And this may appear to say menes, but that's means. That's just spelled by people that can't spell. That's how they spell means. And you're probably thinking, wow, that looked easy. What can be complicated about that? That was, mind you, 2 classes in 2 dimensions. That's the same number of classes and dimensions, right? The Netflix prize data set had 17,000 dimensions or something like that. Did I make that up? Netflix prize dimensionality. Well, this is useless. Someone figure out the dimensionality of the Netflix prize data set and then shout it out in 2 minutes. Okay, so that should have looked and felt easy, and it should look and feel computationally easy. It is not that expensive to calculate some means. In that case, we used random cluster assignment, so just any possible clustering was considered, and that was just to seed the algorithm, right? We computed the means, and they were quite close to each other because we did randomization, right? And then when we recalculated, we started beginning to bifurcate the data set. One of the things that this suggests to you immediately is that, wow, it matters a lot what the initial random seed is with this because those 2 means are really close to each other and they just happen to be cutting from the top left to the bottom right, incidentally because of how they're positioned, right? When I was getting into k-means clustering, there was a very popular algorithm called k-means plus plus, which was definitely written for the first time in C++, right? We can tell that by just looking at it. And it just played with the initial seeding somehow and got some better results. And I don't really know how this works, but you should use this as your final project if you're looking for something to do. Final project for this program, probably not for this class. This matters a lot. Separately, I had to pick a value of k, right? So this is all a little bit too easy and a little bit contrived when we're just looking at the most basic example. And I think classes in the afternoon more popular is like not an exciting emergent thing to find, right? What we really want to find is that classes that combine Alonzo Church's lambda calculus and left Hegelianism are very popular, right? And I have not been able to demonstrate that yet. Does anyone know who Hegel is in here? Really into contradictions? Philosopher? Pre-Marx? No? Okay, all right. Don't read Hegel. Okay. My mentor told me I wasn't allowed to read Hegel. And look at me, right? How weird am I, right? Okay. So with high dimensionality, we start paying very high costs very fast because we're commuting means across large data sets. And this is the thing I worry about so much with so many of these things. These dimensions aren't scaled. It is a little bit too easy with something like the Craven speed dataset, and I've seen this so many times, where you might have a per unit cost and then an overall revenue. Remember that example when I had to calculate profits? So if you do k-means clustering with overall revenue and per unit cost, well, one of those things is like multiplied by how many of the units you sold, right? And they're highly non-independent. One of those numbers is going to be much bigger than the other ones. Revenue is always going to be much bigger than profit by construction, right? So you really might want to be scaling all of these things. We remember probably the Box-Cox algorithm. We remember normalizing, scaling, all of these matters. You're going to want to do that with k-means because you're projecting this into some higher dimensional space. And in this example, right, everything is neatly distributed from -2 to +2 in both dimensions. And we go a little bit past negative and +2 here, right? But what's a little bit past negative and +2 between friends, right? That's not a big deal. So this can get very sketchy very quickly. The example we have for deep learning next time shows dealing with scaling is a persistent problem, and it is really bad, really fast with unsupervised learning, right? I think with supervised learning, you can frequently see, oh, I have some narrative reason or some prior expectations, or I have this idea that suggests to me that like maybe one of these inputs is more important and also has some larger values in it. And we can sort of hand wave our way through it. And we don't really get sort of the intellectual rigor of the full process. But especially when we're looking for things that we don't know what we're going to find and we don't know what to expect, we probably want to scale. So how are we going to deal with that? We are going to look at the wine dataset. This is the classical wine dataset, and you'll see today we are using tidy text, tidyverse, and we've included stop words, which means you're very likely to see something called, I think we always called the function wine words, right? Remember that? And another indicator that we're about to use wine words is we can scroll over here and see we have row ID to column ID. I think I've added IDs to this data frame about 15 different ways in our exactly 14 classes that we've had this term. So I haven't figured out the way I like to add IDs to data frames, but this is the way we're using it this week. And what we can see is that we are preserving ID, and then we have a few other things. We're obviously going to decompose that description into features pretty soon. Did I post the markdown today? Okay. Okay, so this is our data frame. We're used to our data frame. We're going to work with this, and we're going to k-means it. Okay. We're going to relate words to IDs. What is this? This is just the basic idea of wine words, right? We've seen this before. We take the description and break it into words. We remove the stop words. We also remove wine, flavors, Pinot, and Gris. Well, I didn't go wine tasting. I watched 2 other people do a wine tasting this weekend, and it was great fun. I'd recommend, I guess. I had fun. I think if you like drink, I had an espresso, of course. An espresso at a vineyard, it somehow tastes better. So I'd recommend doing that. Okay. Wine flavors, Pinot Gris. We went to White Rose Estate, vintners of the neoclassical Pinot Noir, and they pour 5 different Pinot Noirs made with different yeasts. So if you want to be a wine snob, I think that might be the place. If you're already a wine snob and I'm wrong, let me know. But let me know in the comments after class. Okay, so we're going to count up our words. We're going to group by IDs. We remember all doing this, right? And there's just a variety of mutations and so on. As I've experimented with doing this sort of word nesting a gazillion times throughout the class, I've noticed that some of these lines you can take out and they don't really make the results that much worse, but they do make them less rigorous, right? So this mutating by existence is one of those things that doesn't affect that much, but we should do it for best practice. We extract the top words. How do we do that? We just do a join on ID. We group by variety, and we take the top 3 in each variety. So, apple, fruit, oak, pear, cherry, finish. I think we've spoken about oak and cherry like 100 million times, right? It's not surprising that this would be what pops out. So these are our top words. And then we're going to engineer features for each of these top words. And this is all just so we have something we can start k-meaning. Get it? Meaning, right? Because the verb form of to mean. Jeez. Okay. What do we have? We're going to extract the top words, of course, right? This is the wide pivot to get columns for each. Throw them back into the IDs. We're going to switch to log price. Why? We've already discussed the importance of scaling, right? So we're going to apply a series of mutations. We're going to log price, and then we're going to scale both the price, which is now logged, and the points. I'm still a little bit weirded out by the points range, and I'm pretty sure from 80 to 100, right? That seems like a weird range, so we really want to scale that every time. You don't want something that starts at 80 and goes to 100. At least in that case, it wouldn't matter that much, but it's only going to range over 20 values, but the prices are going to range over many values than that. Wines can cost much more than $20 and much fewer than $0. That's not true. They can't cost fewer than $0. That would be cool. Some of them they should, right? Yeah. Really, we could classify tap water as an extremely weak wine. But tap water is not free either. The cost is just paid by society. Where was I going with that? We're going to move on. Okay. By golly, there's a function in R just called k-means that does all of this for us. You're spared. I was gearing up to teach you Lloyd's algorithm. I was so excited. I love Lloyd's algorithm. It's this like iterative thing where you do like gradient descent across n-dimensional algorithms. Anyways, go look it up if you're computationally inclined. You can probably code up Lloyd's algorithm in like an afternoon if you have enough espresso. And you can do it as I demonstrated. You can write it in my first language, C, right? Which I wouldn't wish on my worst enemy, but it's possible. But in R, we simply k-means, and we have an intuitive sense of what k-means is doing, so it's not too bad to hand wave this here, right? I think we've hand waved some kind of silly stuff at various points through this term, but k-means to me is quite intuitive, so hopefully it's not too bad to just call this. This is going to return the clusters, and we can see the centers of the clusters, which are their positions in n space. N of what? 1, 2, 3, 4. Oh, wow, that's so hard to count. Are there 8 columns? Does that look like 8 features? Oak, finish, fruit, cherry, pear, apple, price points, right? Wow, price points really sounds like it should be one word, right? So we have our 8 dimensions. Now, it is hard for me to visualize things in 8 dimensions. But it's not that many dimensions, right? And probably we can just pick like the 5 of these that matter the most and do it in 3 space with colors or something. If I really had to visualize this, which we're going to just visualize components of it, I suspect the way you do this is you do X, Y, and Z, red, green, and blue, and then you do like size and shape, right? And you could kind of get up to 8 dimensions visually. Do you all know how to do that from your data visualization class? Yeah, so you can figure this out if you need to. Doing size and shape gets a little sketchy, but right, like I think it makes sense to do a shape on points, right? Because there's going to be fewer things at high points, so you want them to be bigger and pop out visually. Now, once we have done that, what we can do is we can add the clusters back into the data set. So I called this wink, which I think is hilarious. That's wine K, right? Yeah, it's the K means of wine, right? Wink. Ugh. Am I less funny than normal? I feel as funny as normal. Like, I'm cracking myself up. Okay. Ooh, I talked about the news earlier. That's a big downer, right? So I'll do my k-means clustering on topics I can bring up. Nosferatu 1917, very popular. Okay. You all liked it when I made fun of James Cameron, right? That was popular. No, no, really? An Avatar Way of Water appreciator? You're a James Cameron fan. You've never seen Avatar: Way of Water. Titanic. Goodness sakes, we might just do movie night. Okay. They won't let me teach cinema studies because I would only show Nosferatu 1917 over and over again. I'd be like, now we're gonna watch the second best film. They're like, is this Nosferatu in English instead of German? Be like, yes. Okay. So we can add our clusters back in. What are these clusters? Okay, they're one indexed, right? How many clusters did I make? 3. Those are the 3 centers, right? So k of 3. Kind of odd to me, it's called centers instead of k. I didn't design this function. That's okay. So we have our clusters over here. 1, 2, 3, 1, 1, 1. Okay? So each of these things are built into some form of cluster or the other. Right. Can we already begin to speculate what some of these clusters are? Why, yes, I think we can. Let's just look at price, points, and cluster. All of the ones have a negative price in points, which means to me below median, right? Probably not below mean. All of the 2s have a positive price and a negative point value. Positive price, negative point value. And then the 3 has positive of both. So it looks like our naturally occurring clusters are bad, overpriced, and posh, right? So one of them's named after one of the Spice Girls. If you want to be my lover. Okay, that's all I got. I don't know that whole song. Okay. Do you know all the words, Kendall? You're still cranking over there. Okay. It came out after 1917. And it was not in Nosferatu. Okay. I think it's unsurprising I wouldn't know anything newer than 1917, right? Okay. So, I've been credibly and reliably accused of being a little bit too into programming language theory. So, of course, rather than write that code a bunch of times, I wrote a function called cdensities. And it takes a data frame, which is, of course, going to be a wink, and it's going to take names. The names are going to be used in a pivot longer to describe the feature, and then we're just going to plot the comparative densities, right? And then we're going to take the features out. So let's take a look at this. What do we have here? We have finish, fruit, and oak, 3 of our 8 features, right? And we see that they are differently distributed within the various clusters, right? So either we can have many finishes, few finishes, much fruit or little fruit, and the same with oak, right? And this is across the clusters, right? We can have many apple or little apple. Cherries pretty evenly divided, and then we have a very high pear. And then we also have different distributions of prices and points. Notice, and one thing I want to point out while we're looking at this slide, right? We really did center and scale this pretty well. Like 0's going right through the middle there. It does look like we have a bump over here, but it falls off more. I guess I would expect price to have a long tail because it is hard to find wines that cost fewer than $0, but it's probably possible to find wines that cost more than $3,000 per bottle, right? So the existence of even one of those would suggest a very long tail, right? Points, not so. This is definitely demonstrating clustering probably around 90, right? Because that's got to be 80 and that has to be 100. And we can also try this with different numbers of clusters. So I wrote this as a map from 1 to 9. I think using one cluster isn't very exciting, but it's at least interesting to see what it looks like, right? Created a function that is going to apply k-means with k clusters, and then we're going to look at the clustering. I had to fiddle around with this a lot because I had a hard time figuring out a reliable way to extract the cluster, what I think of as a vector, but it's a vertical vector that lines up with a data frame, so it's a vector that's supposed to become a column. So that's why I have $cluster here, which is extracting the columnar data, right? It was a little bit goofy to get this thing to reliably return things that I could play around with. So actually, the overwhelming majority of my debug time on these slides was working on this cluster extraction here. I want to show you what one of these clusters looks like. This is K-clusts 7. Remember, I generated K-clusts for 1 through 9, right? 1 through 9, yes, 1 through 9 clusters. And each of those is going to be basically a series. I think it's going to be the mathematical formulation of a series, right? Or is it a sequence? Mathematicians, is it a series or sequence if it's a bunch of numbers in a row? We're going to call it a sequence. And if it's not a sequence, no one tell Aaron McNicholas, who's the person that the undergraduates tell on me to when I get a math problem wrong. Did I tell you the rational numbers joke? Okay, so right, so there's the integers, which are the whole numbers. There's the rational numbers, which are the fractions. Then there's the real numbers, which are the poorly behaved numbers that should get in trouble all the time, right? And so I don't like the real numbers because I'm a computer scientist and I don't want to think about what 1/7 is because it doesn't have a terminating decimal representation, right? Anyways, the most poorly behaved real numbers are the transcendental numbers, and I don't know what that means, right? I think they're maybe not the roots of polynomials or something like that, but one of the most famous transcendental numbers is pi, right? And I could tell you what pi is, but it would actually take me an infinite amount of time to express it to you, right? Because it's a non-terminating decimal. Anyways, when I was hanging out with the undergraduates, I said, well, pi is a rational number that can be expressed as a fraction because it's the ratio of the diameter to the circumference. So it's a ratio, so it must be a rational number. Anyways, if you get that, you've spent too much time with mathematicians, but I hope you enjoyed that. Anyways, you cannot say that around the math department, right? They will beat you up. And they are like very, very experienced fighters because they've had to defend numbers for many years, right? Numbers don't have their own defense mechanisms. Okay, so there's a lot of data here. Is it data? It's kind of information at this point. It's probably not data until we throw it into the data frame. What do I want to point out? This is K-clusts 7, which means that this is the cluster assignment for 7 clusters. Now, an astute observer will notice that there are no 8s or 9s, but there is every other numeral here, right? This would be a little bit more fun if I put in 9 and you would notice there's no double wide columns, right? So these are all single digits and they're all capped at 8. So this is just the assignment of wines by ID to their corresponding cluster. And this would look the same for any of them. I am soliciting feedback. I've written a variety of pretty terrible looking for loops this term. This, to me, is really unappealing code duplication. Do I have Notepad? No, VS Code. Okay. So let me show you what I'm talking about here that I don't like. Did I open it? Okay. These are the classes offered next term. You'll notice many of them are in the afternoons. Okay. What did I do? Okay. So I don't know how to block highlight in a web browser. I am looking for a way to write a for loop that performs a mutate, assigns a column name. I want to do a looped mutate where I generate column names procedurally. So I would probably, I'm fine calling it 1 the numeral, right? Do I have R? Oh. That's all. Okay. I thought I had R working. I could not figure out a way to do this. So the thing that's bothering me, and I will stop talking about programming language theory in a minute, right? This is not a character or string data type, right? It's a symbol, and that's why it's not in quotes. And I don't know a reliable way to get symbols into R other than by typing them in individually. I don't know how to write a for loop that generates symbols. Now, on one of the assignments, I figured out a way to do this. Using So I mentioned their symbols. There is an R function called sim that I think converts a string. I call this a string. Do you call these strings? Yeah, okay. That converts a string into a symbol. For some reason, I had to double negate it and then use I call this the walrus operator because it has like eyes and long fangs, right? So I used a double negated symbol application. I couldn't get this to work with the K clusters, because the K clusters are full column data, and this is a Boolean, right? So I couldn't figure out a way to get this to work. If you know how to get this to work, tell me. Do you know? Is there anyone?
I used to think called G. Made like a URL column. So then I made the URL link link to an image and I can put it into a
Okay.
oh,
Send me your code. I'll look at it. Um, okay, I'm going to say one thing. The column headers are strings in Python. Okay, I had to say it. All right, we're moving on. You're getting me out of trouble. Okay. This is way too small, and I didn't know a graceful way to show this. So I wanted you to see side by side how I am visualizing these clusters. I think I just have price and points on here. I think narratively it makes sense to just look at price and points, right? And then we can do the 8-dimensional visualization thing using all of the various techniques we've seen. But I just ggplot winks, price points, and I'm coloring by its cluster in the 2 mean example. So let's pop this open. What I thought was so cool about this is I showed you the extremely contrived example of circles and triangles earlier, where you just made up random data, threw random classes at it, applied k-means, and cut the data in half, and it happened to go from the top left to the bottom right? Just coincidentally. We did that same thing with an actual data set, right? This is actual data, collected from wine enthusiasts and others. And by golly, we got the exact same behavior, right? This is some kind of quality division between wines, right? It looks like, essentially, with a K of 2, we're very close to only considering price and points, but can I zoom in? We know that the other data is being considered because of this point right here, which is in between things in the other classification. So somehow you can have some kind of weights on your other features that causes you to be classified somewhere other than where you would expect based on just price and points, right? Let me zoom all my way out, which is not going to be easy to do. How do I? Control minus. Oh, that's too small. I have no idea how computers work. Okay. Oh, it's this button. Okay, there we go. So this is a K of 2. My impression, I looked at a couple K of 2s. They have to be just these bifurcations, right? I don't see another way you can do that. Now, if you get enough dimensions, you might not necessarily find where the bifurcation is in your data set, right? But fundamentally, there has to be a plane cutting through the data at some angle, right? And so that's a K of 2. This is the maximum K. This is 9. I have linear colors here, which was probably a poor design choice. Please don't tell Professor Katada Smalley that I don't know what color is. Separately, I also don't perceive color in the world. I see exclusively monochrome. I either see black or silver, because those are the colors used in Nosferatu 1917. Okay, so here we see a lot more sophistication. It appears there's some form of cluster around here, right? But we see little points getting mixed in, right? Looks like we have maybe another cluster up here with other points being mixed in. And this is just all around much more sophisticated data, right? We still have this really strong, should I call this like vertical stratification where the points are heavily binned and prices are not, right? So we have these lines breaking out. Can't really do anything about that, short of tricking critics into using real numbered rather than integer scores, right? Maybe you could score a wine 80 plus pi, right? You could do it. And so this is just what it looks like when you have more of them. I think the most interesting one is probably 3. And that's because with 3, I was able to still really visually differentiate 3 clusters. There seems to be a cluster up here without tight boundaries, right? We've got some intermingling, probably caused by the apple or pear attribute pushing something in a certain direction. Then we seem to have an intermediate cluster in the middle, and then we have some lower tier cluster at the end. One thing I started thinking about a lot when I saw these relatively small numbers of whoa, what was that? Oh, it's the Bitcoin Genesis block. Buy crypto. Okay, do not buy crypto. Sorry, that just came out. That's wrong. Sell, get rid of it. Okay, actually you can't sell it, of course, because no one wants to buy. Okay. Anyone in here love Ethereum? Okay, all right, that was a test. You all passed. Problem is, when you teach computer science classes, they all think Bitcoin's real for some reason. I don't know who told them this, right? I've been saying Bitcoin's fake for years. Narratively, to reflect on the dominance of price and points, every single wine has a, we'll say like non-binary, non-Boolean price or point, and then we've given it 6 additional Boolean features, which are like has apple, has pear, has cherry, right? It is quite unlikely that any one wine has any of those features, right? Now, in aggregate, cherry appears many times in the data set, but I think it probably appears in like surely below 10% of the wines, right? So you're not going to get that much deviation from price and points. Also, even scaled, right? Prices ranging from -2 to 4, and points are ranging from, I guess that's -4 to 3. Those Boolean values are going to be 0 or 1. So you're just not going to see that many of them coming up, right? So price and points are going to have to be dominating this. I'm wondering if a healthy way to do this is just like multiply all your features by 7 or something, but that seems crazy, right? That seems like that would be way too much input. I don't know. But anyways, you can see, in my view, 3 clear clusters. You can kind of pick out 5. Sort of 1 here. I can't see it that well on my screen. Okay, it's pretty good on this one. 1 here, 1 here, and this one's split. You can almost see that it looks like there's some kind of linear combination cutting this in both dimensions, right? And we've got 1 here and 1 there. So the 5 are kind of arranged low price, low points to high price, high points, but there's definitely this like value wines and then like overpriced wines right around the center. And then here's the last one, 6. And you'll notice at this point, I realized, hey, wait a minute. Those clusters are a factor. So I should color them differently. And you could argue maybe you can see this better, but perhaps a cluster pops out here. So maybe this is the mediocre wines, right? Here's the slightly bougier wines. Here's the contenders. Here's wines you shouldn't spend your money on. Here's the value purchases. And here's the wines that you get in a box at Trader Joe's, right? Shout out Trader Joe's. Any Trader Joe's appreciators? Is this more of a Costco place? Love those hot dogs, right? Yeah, okay. I live in Portland where they don't have grocery stores. They haven't invented them yet. Okay. I buy my groceries here and drive them back up. Okay. Wait, what am I doing? I can't just show you that without an introduction. Okay. Wait, no, we skipped something. That's definitely a skip. Okay. Oh, it's group exercise o'clock. Oh my gosh, you all love group exercises, and it's exactly 8:46. That's when it was supposed to be. Okay, so notice we've italicized the K, right? Do you all remember the bank churn data set? Do you all have that somewhere? Yes, you do, because it was part of the modeling assignment, which if you haven't started on by now, that's a you problem, right? Um, K-means cluster, columns 1 through 12, which are age through credit. It doesn't seem like we should be discriminating on basis of age, but I'm not totally familiar with financial regulations, so we'll just do it. I'm not going to think about that. Okay. I would like you to practice labeling. I would like you to construct narratives, right? We have provided from our colleague, Hendrik Oram, who's teaching this exact same class, probably in a way that makes sense up in Portland right now. I found out they did K-means last week, and I'm trying to figure out what week we missed. They're 1 week ahead of us. And I bet it was the week that I made up the random stuff to talk about and called it Voltron. So in hindsight, maybe I shouldn't have done that, right? But it really seemed like all of those topics were important to me, so I don't know. Anyways, add the customer revenue feature, right? So imagine you're Wells Fargo, right? And what do you love? Money, right? And so you don't really love customers, you love how much money your customers can generate for you. And the way to figure out how much you love someone is you multiply their revolving credit by 0.2, their transaction count by 0.25, and then subtract 15 from their contacts count, whatever that is, right? But these things are all present in the data set. And then density plot the clusters versus this revenue and revolving balance. Is this a 45-minute task and then I talk the last half hour? That's what it sounds like to me. Okay, I'm going to set the timer for 30 minutes and we'll see what our feelings are like at that point, right? Okay. You can, that is not the button I meant to press. Anyways, get going. I'll pull up those slides again. Okay. Oh, right. I can, yes, okay. I know what's going on. I have new keybinds. Just have something open that says Ambiguify. um, do not need that. No. Okay. I felt bad about using the browser for timing. No, I'm thirsty. I have to carry this water around. Okay. That's 1.2% of your time. I would have called it sponge getting distorted again. So they should stop down. Anybody else at all? You know, sort of down with sleeves, yeah, right. So this is against one of the string breaks. Where's that? Just saying over. I'm just kind of seeing on like that. Yeah. I kind of like this. This is doing great things for my blood pressure. Yeah. That makes sense. Like I really love it. Yeah. Would it be less stressful if I did it every 10 minutes?
Just like no, I think which ones I can. Then auto. No, I just hit. I'm just checking. Those.
Well, no, we have. So that one. Yeah. I was gonna make it like. Yeah.
Okay. Oh, okay. It was it was actually awesome.
Right, 11.5%. Have your 11.5% done. Plus,
Yeah. It's all default settings. And many things do not even default. So it's a default like this. What is this?
yes.
So
We definitely help. It's not like, you know, like, it's always things. But like, last was plus for now. So I feel like, hopefully, all the. Yeah, this is all crap. A bunch of sorry. Sounds like. Set you about conventional. Yeah, well, we call it principal fund now. They're so interesting that they're getting to that versus the out. Thank you.
I have no
It's awesome. Well, like, awesome. Yeah.
I was. Yeah, my seconds. So.
You stuff. I guess. Yeah.
I went to school from. Yeah. And then I was thinking, why is it not connected? Except for when it does do this, and I'm super worried. I can do it. I told you that it would be because you have every time there was a way I can back us like the guy once. It's the more. It's like about it. I mean, and keep friends people. What we do. I just blame everybody. Okay.
Yeah, I can't figure out how to get that error message. It is. Yeah, yeah, like every drop it. Okay, it's just like that's largely. Well, I used to and I'm going to Mississippi here for 30 years. Yeah. Politics are doing the same. Yeah. People don't work, like for example, you're not going to have great, so just go elsewhere. And they treat the same way, and they go there. I mean, if you run into issues, because they're not in the shared branch network, if you're going, they go like across the country, that's how they work. When you make the first step is merging with digital pricing, just it's easy to because for a package over the individual credit union, these things was already big. So you have. I don't even know about them because of my. It's about okay. But then I didn't, they were gonna marry eventually. So but at least like that gives an option. And in Japan, where you supposed to sort of there, all that at my work. All that you'd have to do something. Do what they did on the day. You'd have to go to the advertising. Post the service. That's how they did it. Mhm. It is. Oh, look at this. Like, what's really neat is having fun is it's the credit union. The credit union has to look at it on the mountain. So it has to be like it has to serve like a certain like delegate probably with it. It's also something like state employees or for example, public employees for a while. And rules, and then they open Washington. I remember when they did like buy them. That was great. What was really cool about it, even if it isn't necessarily the same for all gamblers, is that you see all the public betrayed, they already have to like look online and it's just stuff. Even you can go on a scale, look at their accounts. So you can see the word one GC paid because they're technically considered 13, 14. One of those, but it's all public, so we can. And the rooms to the numbers. Oh, okay, well, it's kind of for the ones that get scared. Number. It's fun. Yeah, we should take yeah. Those can be bad. Oh, so stop. Oh, yeah, that's awesome. There's two. I'm not religious, but I still don't think guys. Um. Yeah, so it's probably like all the shit out here and it's here as well. It's very just. There's some of that.
Yeah, so.
Yeah.
So in order for something to. We have examples of these things are like these things which are most. We're doing. Where we here because we're staying, it's really it's out of the there's no circle. Because we have no sense of the game of this. Each word or so no like and depending on how many progress like we feel all the graduates then like the word you say and one asks that'll put you in your majority zeros that would put you as swimming. And that's what clustering case offers. And so it was definitely the answer. Eventually features to deciding what that can be on survey. You don't have to read it. That's why it's
Oh, it's. I wondered. Yeah.
I don't know if it's I keep my complete check. It's just to me, it doesn't matter. No, yeah, I didn't say.
Yes. Oh, it's been. Sweet. Yeah. Oh, great. Right. I remember.
I just found it interesting, and I know God, kids are all. Was one of. I would have been to do this.
Oh, I think that's. Wow. Wow, I did. Yeah. This is. I like the girl here. I saw it. It is. Breaks it. Really bad. It's really basic. Seriously. No, it's not fair. Yeah.
That's odd. Like, this kind of, it's like, yeah, yeah, that's. You have to see it. Research. It's so it's on site. Maybe every movement at times. All around. Yeah, no, they didn't know anything. I like essentially at the office. Real bad. To the right. Oh, I didn't buy it too. No. Oh, gosh. It would hurt. My dog. It's not bad, right? Actually, we were in a city. I'm always most not graduate. Is that there?
I think you can. If I look at it. But this is. Act is a kind of important. Sure. See it's right. Like, yeah, education. Yeah. It's okay, right? It's actually so we get started. 60 hours covering the food projects, 6 hours for this project. Those people can on the project gets like it's so written. I did show, oh my gosh. So you are you familiar with So, probably, I think, something that's which is coded in the section at the bottom. There's 12 features which yeah, that's what it says. Starts right now. Words and I don't make it but it that reason it's true. Or mine one is that obviously skill and they basic skills. I like it. Maybe like this is like just whatever the house, yeah, just there's both. So upside down. Right. Sure. These swords. Slide over. Probably 6%. Those things. I feel like you're like to get it actively. If that doesn't your you can tell them to move part. But technically the ones that are right. I don't think so. Maybe this there as well. Yeah. Yeah. On track dating. Okay, let's do this. Right, so probably this is it's like you take same thing. Like most of the ones I think is a nice and none of us but meetings so I just and oh, just yeah.
So there's a gift thing, you just search baby for some answers. I don't think he has to do that. Yeah, so it is so watered down. Yeah. This one's angry. Yeah. Yeah. Still like, you know,
so is that like for and they for all the devices you said in steps. That makes sense. This is what I use. So it's just like pretty cool. It's how I got a little bit of input on it. If you just change your application. I just like found some peer that yeah. Well, I read about church like that was used fake, right? If it gets better, if it gets better, wrongfully programmed serial right? It just keeps getting better. Exactly. As long as I believe, at least whatever I say, that's right. There it is. I know it's not even go. Yeah. I think the thing. And I didn't want to. I could have made it on. So now it's. Completely lost. Okay. Yes. Wait, there's two of the long. They it's it's a little bit like I do sense of and it has its own like language to it. Each of them. So it's funny. I still don't know. What's your That's the first sentence. Right. I know I see them. 45 minutes. All right, I'm gonna refill my water and then we can talk some more. Yeah, see you soon. So let's look for 25 to 800 bucks for a perpetual. Aquariums, annual, yeah. Standard, standard. Point of behavior. Standard, we can see. Holy. That's what I think that's. If it's so many items in iron faucets, you can have up to 20 million observations. No, they don't claim their own stuff. If I'm. That's really great. Yes. This is one of those.
Minecraft and Swimming so we're to make it properly with items. And
Oh.
that I need to read.
Yeah. Do you want to go on it?
Yeah, it's just too weird not to.
Okay, because I was trying to jump up the stats and it said it wasn't just over the house.
Okay, yeah, just use a different one then. The really strong one is the Google maintains the SDK, and that works on everything. But that's a big file because it's Eclipse, it's a Java runtime. But if you're interested at all in what your websites look like on mobile, I'd get this and use it. I used it for years. I stopped using it because I don't write that much Java. Um, hello students, welcome back. Um, I just like this isn't related to anything. Thought I should show you the code I wrote. This is in Python because I couldn't get R to run, but you know what while loops are. So I have x less than end, and I initialized that. I just set x equal to 0. That was the number of seconds that passed. And I set end equals to 30 times 60, so that's 30 minutes, 60 seconds per minute. Well, x, which starts at 0, is less than n, which is the total number of seconds. I sleep for 1 second, so I got that from you import time. You can see what the current time is, and that's, I think, like seconds since 1980 or something, right? But you can also time sleep, and I don't even know if I can put a 0.1 in there, but you can do any amount of seconds, right? So this is kind of cool. When do I use this? So these things are written in Quarto Markdown, and Quarto Markdown has something called Quarto Preview, which is supposed to monitor your file and then update the website. I thought that was too slow, so I actually just wrote a custom script that checks every 1 second to see if my file has updated, and then it re-renders, and rendering is the full workflow that's more powerful than preview. Anyways, it's a great joy. So anyway, like writing these little scripts is probably not something that immediately obviously seems like it's part of data science, but actually the only time I've ever written something like this was to make Quarto Markdown documents, which is like the most data science thing you can do, right? And it was just a little bit too much nicer for me, given my workflow, right? So I think many of you love RStudio, and I support you in doing that. RStudio is a very highly regarded IDE. I also don't really love VS Code, which is also extremely highly regarded. Many of you like that. I write my Quarto Markdown in Notepad, and then I just have my browser that's auto-refreshing every time I Control S, right? Super cool, and it's like, to me, it's just a fundamental part of the data science workflow. So I thought I'd show you these little things, these like sort of time-based loops. You can write this in any language. You can write this in Go. You can put this in a browser. You can write this in JavaScript. Some of you know JavaScript, right? So it would make much more sense to do this in JavaScript, probably, right? I don't remember how JavaScript works. Can I sleep? There's probably a way to sleep. Wait, I did an exclamation point. Um, so anyways, just, think about these things you can do with scripting other than directly manipulating data frames, right? There's a lot of niceties you know how to do. Um, I go out of my way to write a script to do something, even if it's not the best way to do that, just to get in the practice of doing this all the time. And every once in a while, you automate something and you're like, wow, that made my life better. Not every time, but sometimes. Very good. Okay. We'll quickly talk through this solution, and then I'm going to introduce and basically tell you not to use hierarchical clusters. And hierarchical clusters were the other example of clustering we showed at the beginning of class when I introduced my research program. All right, so we grab the bank churners RDS, we drop the NAs. Looked like our most common error was having infinities or NAs in our data frames. That will always be your most common error. You know that from data 501, right? Data cleaning, data wrangling, it's just a hassle. Be responsible about how you deal with that. In this class, where you're just here to learn machine learning, don't be responsible, be fast, right? Just get rid of stuff that doesn't help, right? And if you find something interesting, well, like maybe you found out why you're not supposed to drop NA, right? That's still a positive result. So, and I've blocked this out into the stages I said you should do, right? Okay. So we're going to load bank churners. We're going to take age through credit. That is just the no, sorry, we're in R. That is the 1st through 12th columns, and they have these names. And what did I do? I just dropped NA again. I just put drop NA every single time, and eventually the code starts working, right? Is there a responsible way to do that? Yes, but that's not the point of this class, right? And so here's the names. And so what are we looking at? We cut everything after credit limit, so we're not looking at total revolving balance or average. Wow, I thought that said utilitarianism. That says utilization. Those are different words. I asked my partner what utilitarianism was at dinner the other day, and she said, I'm not going to be quizzed about philosophy, which I think was an extremely boss response. So anyways, just look forward to that one. We engineer features. Some discussion around this. This is an example of extremely low effort feature engineering, right? I just wanted to show you something that works at all. You should not do this. And so I think many of you ask questions like, why are you doing this? Because it's fast, right? It's fast and easy and does anything at all, right? And the best example I can see is that you have multiple income categories and I just completely flatten them. That's irresponsible. They should be ranked, they should be numeric somehow. So there should be more sophisticated engineering than this, in my view. Now, we've talked about the specifically education level for a few times. I don't know the total ordering or even a partial ordering, right? So I don't know what comes before or after something. Because I think there's a like bachelor's and also graduate and also high school. And usually you either graduate from high school or your bachelor's degree. So maybe this refers to a non-doctoral bachelor's or non-doctoral post-bachelor's degree, like you're all getting, right? But I don't know. So I don't know what any of these things mean, right? I just grabbed them out. I read Simone de Beauvoir's The Second Sex, so I did not treat M as the default gender. So shout out the second wave feminists and also the French Revolution, right? Anyone really into Robespierre? How about the Jacobins? Okay, I don't know anything about history, so I never know when I'm on the brink of oblivion. Okay. Just picking out 4 clusters. I don't think 4 clusters is going to be the right one to use, and we'll talk about that a little bit. But that's based on non-machine learning knowledge, right? So what I notice, wow, those ages look the same. Those genders look different, but those dependent counts kind of look the same. There's the idea that like every suburbanite family has 2.1 kids, right? So like we have, okay. Education level, pretty similar. Marital status, bit of a difference there, right? 3.8 to 4.8. I don't know what the population baseline marital status is. Are people on average married? Probably not, but every marriage creates 2 married people, right? So it seems like marriage should be able to win. Like it would be very easy for it to outnumber us. Income category, just sorted pretty much low to high, right? That's much higher. Card category, that's pretty interesting, right? High income, low card, and on and on. We don't need to worry about all of this too much, but ooh, I'm going off the bottom of the slides, right? But the credit limit goes way up here as well. Okay. I'm going to say one thing, and it's going to get me in a lot of trouble, but I have to say it anyways. I read a lot of Vladimir Lenin. You all know who Lenin is? Russian Revolution? Anyways, Lenin says there's exactly two classes, the bourgeoisie and the proletariat. And then Lenin successfully won the Russian Revolution, which I would argue is a form of experimental verification of your economic theory, right? Because I've never successfully won a Russian Revolution, right? And then you could argue that Mao Zedong did the same thing, right? Okay, so anyways, I'm a communist, and communists believe there's exactly two classes. So I suspected that if I did k-means clustering, I would find out that Lenin was correct, right? Now, I'm allowed to say this because Hendrik Oram, who works for a bank and has a math PhD, said the example we should use for our LLM model is training LLMs to talk like Karl Marx, right? So I just did that to my own brain, and Karl Marx really likes Vladimir Lenin, right? So anyways, I did a little bit of Leninism. Please don't tell anyone that I did that, including yourselves. And I said, I bet there's exactly two classes, and I bet they're sorted by income. And by golly, Lenin was completely correct. Totally historically vindicated, right? Look at that. I should note that I do not co-sign the actions of any state actors at this time. Okay. Card category split, but like very interesting, right? Age is pretty much the same. Gender's a little cooked, right? Dependent's pretty close, but dramatic difference in credit limits. So go ahead and read the Grundreis, which I can't pronounce. It's this thing. This is the famous incomplete work by Karl Marx. It's, I think, only in German. And it's famous for being impossible to read, so I recommend you read it. Anyways, so I'm using the Marxist conception of class, and I'm terming the classes the bourgeoisie, which is the ruling ownership class, and the proletariat, right? I have heard that the most terrifying thing you can ever have to do as a professor is attempt to spell bourgeoisie on a whiteboard in front of students, right? Look at that. Look at those consecutive vowels, right? I could not spell that word at all. I'd have to call them the Borgs, right? But the proletariat, that's fine. That's easy, right? So I created a bourgeoisie and a proletariat. And this is all good fun. This is all in good fun. We're all having fun here, right? Okay, we're not conspiring to overthrow the government or anything, right? Okay. Do not put in the Corsi vowels that okay, right. We're going to add a customer revenue feature, right? So we have revolving credit, transaction credit. What's that? This is a simple, what is this? This is a linear combination, right? We're linearly combining things. We're multiplying something and then we're adding it together. Multiply, add together. Multiply and add together, right? That's a negative factor, right? So it's not really a subtraction. That's an addition of something times a negative 15, right? So here's our revenue, which we compute here. Sort of cuts off the underscores there, but that's not too bad. I treated multiplying times 0.2 as dividing by 5, and you all understand arithmetic, so that shouldn't be too sketchy for any of you. And that helps my long-running conception that in addition to there being exactly two classes, there's exactly one type of number, the integers. Okay. Here is a density plot. And we can take a look at these. Is that too small? I think that's too small. Let's open the image in a new tab. Okay. Now, I don't know that Karl Marx and or Vladimir Lenin are eating too good right now. But, did we invert our bourgeoisie and our proletariat? Okay. So we have a high density at low revenue. And we have a much higher spike on the bourgeoisie. And then we have much longer tails on the proletariat going over here. And then we've got this little sort of lump here. To me, this suggests that I didn't quite find the clusters I'm looking for. It really seems like I should have a cut here. And then I should have all of the bourgeoisie presumably in the high revenue bin, or perhaps banks don't make money off of rich people. I don't know. I would suspect they make money off of rich people, but I guess rich people don't pay overdraft fees, right? I don't know how the financials of banks work. I don't know exactly which clientele you want to attract, right? So anyways, we have a slightly higher density at a low revenue value. I don't know what these negative revenues correspond to, so I'm guessing there's people you lose money on, right? And I guess that makes sense if you're a bank and it costs more money to hold on to someone's money than you can make from serving that customer. So that has to be, they put some amount of money in the bank and then use a large amount of financial services that are not high profit margins. So there we have that. We have density plot clusters. I thought I pressed next. Okay. We can plot versus churn. And what do I think I'm seeing here? So to me, this is suggesting that the bourgeoisie, the elements of the ruling class, are highly likely to stay at the same bank. So we have a high, let's see, what is this? We have a high yes. Oh, I don't have axis labels, so we can't actually tell what this is, right? So we have a population that is highly likely to stay at the same bank. And then we have a second population that is highly likely to change, but not as likely as the high. And this corresponds likely to the high lump on one side, right? And proletariat is much the same shape, but everything is a bit lower. And I don't know. That's an example of clustering. Did anyone find a more interesting cluster than bourgeoisie and proletariat? Hold up a hand that represents your K size. So I did 2. No one's holding up hand. Okay, bunch of 2s. Oh, a lot of 2s. 2 is relatively popular. Okay. 4. Okay. Does it make sense why I would rely on some historical reading in economic theory to decide my K value? Right? Come in with prior knowledge, try it. This to me doesn't really look like it worked, right? This looks like I should have used a different K value. Nothing wrong with that, right? I came in with some prior knowledge, I checked it out, didn't seem to be predictably powerful. And to me, this is the thing that really convinced me, right? That looks like I have the same population in both clusters, right? That's just a little too suspicious. So, what I could have used instead is this little thing called hierarchical clusters, right? So many of you are probably post-Marxists, right? And so one of the responses to Marxism is, what do you mean there's exactly 2 clusters? There's many other categories that cause people to be oppressed along different axes, right? So in addition to, for example, the labor movement, where you have the proletariat, for example, union organizations, and then you have the ownership class, like the robber barons like Carnegie, and now our recent batch of billionaires, right? Like, is it not also very important what nation state people live in or hail from originally, right? It's not very important what gender people are identified as, right? And so if you're one of these post-Marxists, like many of the people I spoke to in the critical theory program at PNCA, right, you might want to say, well, maybe we want to disentangle a little bit the different factors contributing to identity to make the most natural way to categorize different things that are going on in our society, such as bank churn. And anyways, that's my effort to explain the critical theories program. That has absolutely nothing to do with this slide. This is hierarchical clustering. So imagine we're back in the case where we exist in 2 space, we're only looking at 2 things we care about, and the example of the 2 things we cared about previously was on this axis we imagined we had time of day, and on that axis we imagined we had course enrollment, and we're trying to get classes moved to 6 p.m. to 10 p.m. at night, right? Because that's the maximally afternoon time slot, right? So we performed a local optimization over that. One way we could categorize this is not with k-means, but by picking the 2 closest points and putting them in the same bucket. And then, once you have one bucket, then you pick perhaps the closest point to that bucket or the 2 closest points to each other, and you build up a hierarchy over time of relations, right? And this is one other way to examine how we might be able to find clusters, right? So these 2 things are quite close together, but not as close as these 2 things. So we put them in a bin. And in our ongoing example, this is let's see, so we said time of day in enrollment. So this is later in the day, low enrollment, which I guess that's defeating my hypothesis, right? Now we've got a problem, right? This point doesn't really have any friends, and so we have to find some friends for that point. And we do so by simply putting it with the closest existing cluster. The clusters, once they exist, operating the same way as points. Now, this does mean that some mathematician will have to go in and do some computational geometry and figure out how you measure the distance to a cluster versus measuring the distance to a point, right? Variety of ways to do that. An obvious way to do that is you just keep treating points and you see what the closest point is in which cluster it's in, right? But you can also say, oh, the space within the points or contained by the points or around the points, or we create a circle or something, right? So all of those things can be handled by your favorite computational geometrist? That doesn't sound right. Yes, your computational optometrist. I tried to get new glasses on the internet and my prescription was too bad. They said you have to come in. I was like, thank you. It's like, I know it's bad. That's why I'm getting glasses. I don't know why I'm looking at these. I already know what my glasses look like. I have contacts. I just don't wear them. So, yeah, fine. Okay, so here's a hierarchical cluster, right? Okay, I'm going to do one more part of the extended joke. Many of the post-Marxists are anarchists and therefore opposed to all forms of hierarchy. Okay, we're moving on. I don't know anything about anarchism. Okay, so I thought I'd call this one swine, which I thought was hilarious, right? Pearls before swine? Pearls for swine? I don't know. That's because it's a sample of wine. Why did we do this? Think about why I'm taking a sample, right? And then we're gonna cluster, which is H clust, right, instead of K clust. And we're gonna do that over swine, right? And I think this is distance. I don't know. It worked. And here's our cluster. So, blah, blah, blah. Lots of organization, many lengths, very high height, right? And what does this height tell me? Well, I put exactly 200 things in my cluster, right? And I have a cluster height of 199. Well, let's take a look at this quickly. What does height mean? It's like, well, we can maybe say this is a height of 1. This is a height of 2. See, it's higher. This is a height of 3. This is a height of 4, and then the top is a height of 5, or perhaps we say this is the highest height. So we can say this is 1, 2, 3, 4, 5 entities, or perhaps wines, and my cluster has a height of 4, right? Because really there's nothing interesting going on up here, right? So my height is always going to be n minus 1, right? This is my cluster dendrogram, and I think I distinctly remember every single one of you saying, I love dendrograms when I teased this earlier. So you all love this, right? And dendro means tree in some language, perhaps Greek. And some of you may have heard of dendrites, which is the neurological structure, right? So that's where I'm familiar with. And what's going on here? Well, we have a variety of different swines, right? So these are, oh, can I do a pig impression? Pigs go oink, right? Like oink, oink, right? Yeah. And they have like 20 ears. Yeah. Yeah. So imagine, no, I'm not going to say imagine I'm a pig. That sounds weird. Okay. So don't imagine I'm not a pig. Okay. We have our swines here, and then we perform a bunch of clusters. These are existing in some higher dimensional space, right? But, we can't project all of that. Now, what is this line doing here? What's that line doing? It's cutting up my dendrogram. I did all of this work to dendro, and then all of the gram is below the line, right? So we do it for the gram, right? Yeah? Okay, anyone listening? Okay, all right. We need some way to get some number of clusters, right? And with k-means, we just set k going straight into it. Here, we do all of this sort of low-level clustering, and then we can cut at any height, right? And so if we want n clusters, we know we will have a, let's see, I shouldn't use n. If we want k clusters, and we have n entities, or observations, or whatever, right? We're going to have a height of n minus 1, as it's accounted for here. So, at a height of n minus 2, we will have 2 clusters, and at a height of n minus 3, we will have 3 clusters. So there's a relationship between the height and the number of clusters. So we can neatly get any number of clusters that our heart desires by cutting at a certain tree height, right? And so that's what we do here. This is how I split things up and assigned clusters. We clustered, we used distance. I assigned the clusters based on the cluster tree with a certain k value. I took swine and I added a cluster column, and I just added the clusters in as a factor. It just took me a minute to debug all of this stuff. You just try things out and it eventually works. And what we have here now is we have wines that have, I believe, some ID, or at least they have a row number. They're either oaked, finished, fruited, cherried, peared, appled. They have some price and some points, and then they're assigned to some cluster, right? So we have at least 1, 2, 1, 3, and 2. Earlier, I showed you similar data with similar categorizations, right? And I pointed out at that time that with 3 clusters, and I have a k of 3 right here, earlier I had a double negative, a positive negative, and a positive positive cluster. That's not what we have here. This is in the same cluster, this one here, that is a positive price and a negative point value. So above average price, below average point value. And this is a below average price and below average point value. 2 is above on both, and 3 is below on both, right? So I'm fundamentally finding a different type of cluster. I've used a different algorithm and I've gotten different results. This is interesting to me. Do I like these results better? I don't know, right? Like I have to see what I'm trying to predict and see what I value, right? I've discovered some other notion of cluster than k-means. There are other ways to do this than k-means. To my knowledge, no particularly graceful way to visualize all of this, but we can see. I have colored my clusters here, RGB, and we can see that, wow, this is so hard to see. Can I see it better on this screen? Not particularly. Blue is not particularly dominated by finish, but green and I'm assuming that's red overlapping with the green, are highly correlated with finish with a strong binning at the no finish for these 2 clusters, right? There's also a strong push toward fruit. But something I really see here is these clusters seem to be lining up on top of each other pretty well. Maybe I have the wrong number of clusters. We're definitely catching apple and pear for 2. So it does seem like we have a fruit cluster, right? And then we're capturing a little bit of cherry with red. Now, I think we may recall previously in this data set, we've seen that cherry is not correlated with the other fruits. So it's not too surprising to see this breaking out on different clusters. We have a strong yes pear, we have a strong negative pear, and then we have a strong negative cherry. So no cherry is associated with yes pear. And I would argue a little bit with yes apple. We do have really strong stratification with points, which I think is pretty cool. And pretty good with price. Now, my impression is that this actually got very, very close to pulling out the varietals, because I remember seeing the varietals and I remember what they looked like. I'm guessing green is pretty much finding Pinot Noir. And we could figure out how accurately it's finding Pinot Noir, right? But just in our closing thoughts, how many minutes do I have left? 4. Okay. And I get all 4 of those minutes, by the way. Stay locked in. Are you? All right. Okay. I don't know what you do to lock in. I do that. Okay. There's a lot of wines in our data set. And to perform the first categorization, you have to check the distance between every single pair of wines. To my knowledge, that's 2 to the power of the number of wines. That's a big number. So when I did this with 200 wines, I was looking at 2 to the 200. That's a big number. That's a 1 followed by 60 zeros, right? That's large. It would take me a few minutes to count that high, even if I counted by, I don't know, 1 to the 50 times 10 to the 57th, right? So that's a very large number, but it is smaller than Google, right? It does fit in a 64-bit integer, I think, pretty comfortably, right? No, it would fit in a 128-bit integer, which is not too bad. These numbers are infinity. You cannot do infinity things, right? Now, it's not really infinity, right? But like it might as well be. 2 to the 3000th is a very large number. Anyways, I just threw this in my computer and ran it on the GPU and was able to still hierarchically cluster it, but I would not recommend that. I'm guessing there's some optimizations that are going on under the hood that are saving you, but at any given time when you run a hierarchical cluster, you just might run out of sauce, right? So don't use hierarchical clustering on big data sets. Now, what you could do is you could create a sample, find the clusters, and then attach things to that cluster using some other algorithm. This is the reference to k-means. Oh, it's now an article. And I hope you had fun tonight. I had a great time. Go home and get some sleep. See you next week. Deep learning. How do I stop stream? Wow, 9 people are watching? The folks at home are tuning in. Shout out the folks at home. Shout out the folks at home. Rare emoji.